Welcome everybody to your very first video over MySQL. Now I know what some of you are going to be saying. What? This ain't your first video over MySQL. You actually did an entire series over this. Yes, this is actually my second series over MySQL. The reason being is that MySQL has changed a lot over these last few years, and it was just many years ago, so I think I've learned a lot more about MySQL. And I'm prepared to make an even better series. Ha! So that's what we're doing now. Hopefully this series will satisfy you guys who've been wanting some more of MySQL, because this series is going to be more in-depth, more techy and cool and up-to-date and stuff. Alright, let's do this. So what is MySQL? MySQL is a relational database management system. Essentially, a database is a software that allows us to store tons of data or information. So data can be really anything. Think of something you want to store that you can use at a later date. Often, databases are used behind an application. So an application might say something like, hello, and then say the username. This section right here has to come from something. All of this information is stored inside of a database. So this allows us to make apps that are dynamic. What does dynamic mean? It means changing, but only certain parts. So often we'll have an application, let's say this is our application, right? And we might have some kind of code that presents this information here. But it's dynamic in that this username can change depending on who is signed in or what your username is. This allows sort of like a separation between the application and the data that the application needs. So you have the application here and the database. The code itself is going to get information from the database to present to the user. So let's say this user uses this application, does something on it, and that information is stored inside of the database. Well then later, when he wants to use the application again, we can get that data from the database and present it in the application, and then that will be delivered to the user. So this is kind of the key word of it all. We can make dynamic websites, websites that change, websites that render content. So you could make an application that renders your most recent blogs, and you don't have to go in there and update your recent blogs every single day or whatever. It'll do it automatically. That's because you can code it and it will do it dynamically. Now the other part of relational database management system is the keyword relational. And this word right here, relation, actually means table. You can use that at a party and impress all your friends. Okay, so we have a table, and the way things are organized is that we have columns going this way, and then we have rows of information going this way. So for example, we can have a column of a username, and then all of the data in this column is going to be everybody's username. But the way this data is entered into this table is by row. So a specific user, let's say this guy, signs up for an account, he puts in a username, he might put in an email, a phone number, a first name, last name, whatever it is, doesn't really matter. All of this is stored tabularly. Tably? All of this is stored inside of a table. But it's not just an ordinary table. The table is just the way the data is presented. A different way we can think about it is with the keywords entity and attribute. So an entity would be the user or the person. The attributes would be the username, their email, first name, last name, phone number, all of that good information. Now these attributes that describe the entity, these are stored as columns inside of the user table. Now don't freak out if you don't understand how to design all this stuff yet. That's not the point of this video. The real point of this video is to give you a rough introduction to what databases are and what MySQL is. So now that we kind of understand what a relational database management system is, which if you just need like a one-sentence summary, it's a way to store data in tables. Really simple. But now we should move on to figure out what MySQL is. Now as I mentioned before, I have that other MySQL series, and that content is still pretty relevant, so if you want a slower introduction to MySQL, go ahead and watch that. Now MySQL is a management system. That means it allows us to store data in tables. And the way we do that is using what's known as SQL. Now MySQL is just a software system that adopted the SQL standard. This My here, I'm pretty sure it was like the maker's daughter's name or something. But essentially, it's just a software that allows us to type SQL and store data in tables. So SQL stands for Structured Query Language. Structured Query Language. And essentially, this is kind of like a language that's between computers and humans. So here's where SQL goes. That's because a computer can interpret SQL and a human is smart enough to write SQL. So we can communicate with the computer using this language. And that's really what this video series is going to be about. We're going to be learning SQL, but we're going to be learning the MySQL dialect of that. Essentially what a dialect is that it's the way this database system adopts the SQL language. For example, there's other database management systems. There's SQL Server, there's Oracle, and there's a plethora of other different database management systems. But they all have the commonality of using SQL. There's just some minor differences, and that's where this whole dialect thing comes up. So for example, writing something in MySQL is going to be very similar to writing something in SQL Server or Oracle, but there's going to be some minor differences. That's because MySQL has adopted its own dialect. For example, there's extra features in MySQL that are not specified inside of this standard, and those extra features are not going to be the same as SQL Server and Oracle. But even so, if you know MySQL, it's very easy to pick up another database management system such as SQL Server. That's because they're all based off of a standard, structured query language. Now hopefully that kind of makes sense. Don't be overwhelmed with all of the details. What's really important to know is that MySQL is built off of a standard known as SQL. SQL is the language we use to store data and retrieve data from our database. Now there are a lot of ways you can store information. For example, why don't we just use an Excel sheet? Or a text file. Well, there are a lot of benefits of using these, but there's also some really serious downsides. And we'll learn all of those as we go on, and you'll see why databases are so important. But to start off, I'll just give you a couple. For one, Excel is just a way to make spreadsheets. And the thing with spreadsheets is that they are all or nothing. That means if you have a spreadsheet and you want to get data from this, you have to look at the entire spreadsheet. You can't just select certain columns. With a database you can. That's because you have what's known as a select statement. And you can specify which columns. So you could say, I want this one and this one, but not this one. Along with that is security. For example, in a database, you can prevent certain people from doing certain things. In a spreadsheet, you can do that a little bit with file system rules, but it's very limited in that if someone has access to a spreadsheet, they can basically do whatever they want. You could make it read only, but let's say they had read and write abilities. They can do anything. But with a database, you could say, here's some things they can do, and here's some things they cannot do. So you can have a little bit more flexibility, and you can make basically a entire system that allows many users, but you're not going to open up your data to be destroyed by certain people, right? So you can prevent big disasters using a role system. In addition to security, databases also allow us to store much more information. Databases can be expanded to tons of data and still run efficiently. That's because we can separate data very easily, we can index data, and the database management system is optimized to work with a lot of data. Spreadsheets can work with a decent amount of data, but when you are talking like millions of rows, things might get a little clunky and not very organized. So if you're a very small business and you just need to store a little bit of information, I tell you, a spreadsheet will do just fine. A text file might even do just fine. But if we're talking about an enterprise application that's going to have tons of information, in that situation, I know you're going to want a database. So we've talked about what a relational database management system is. We've talked about what MySQL is, but now let's talk about why MySQL. Why would you want to choose MySQL over some of the other database management systems? One reason is that MySQL is open source. That means you can go and view the code that actually makes the database. In addition to it being open source, I think it has one of the most flexible licensing systems, meaning you can do the most with paying the least and being restricted the least. Because of this, MySQL is often used for smaller projects such as websites. Websites often use MySQL. Literally almost every website that has a content management system, think of like WordPress, Joomla, Drupal, all of those, they're almost always powered by MySQL. In addition to this flexible licensing, there is a small learning curve. So you have to learn a lot to use a database, but once you figure it out, your efficiency goes much faster. Whereas a spreadsheet, it doesn't really require much knowledge, but it takes a lot more work to maintain. It's a lot less efficient. You end up losing more time upkeeping and all of that nonsense. But MySQL, compared to other database management systems, the learning curve is small. So for example, Oracle might have a learning curve like this. I'm just drawing random charts, but the learning curve in Oracle, in my opinion, is much higher. It requires more knowledge to get started with Oracle. So for small projects, most people pick MySQL because it's really not that hard to adopt. It just has a small learning curve. SQL Server, well, that's kind of somewhere in the middle. It has a steeper learning curve than MySQL, but it's not too bad. So if you really support the open source community and you like flexible licensing, if you're that kind of person, I'd go for MySQL. But if you're looking for a world-class, 100% reliable, has to work all of the time, like a crazy application kind of thing, I would go for Oracle. And if it's somewhere in the middle, maybe SQL Server. It also often depends on what code base you're working with. For example, PHP, people almost always use MySQL. C#, people will often use SQL Server. And the reason why is just that certain languages work better with certain database management systems. Most websites built with PHP use MySQL. Does it have to be that way? No. Does every website that uses PHP use MySQL? No. It's just the way people do things. So it ultimately depends on your goals, what you're trying to accomplish. But either way, I think MySQL is a great database management system to start with. So that's what we are covering in this series. If you like this video, please click like, subscribe, and go through this series. I promise you won't be disappointed. Thank you guys so much, and I will see you in the next video. What's happening, everybody? Welcome to Caleb the Video Maker 2. I'm Caleb, and in this video we are going to be downloading and installing MySQL database. So we go to the mysql.com website and click Downloads. Now there's a couple different things you're going to want to download. The first is the actual database. And if you scroll down here, you can find MySQL Community Edition, and that's the free version we're going to start with. So what we are going to want is the community server. Now, if you need in-depth information on how to install this, you can click the installation instructions right here, or you can just follow my video. Now, you're going to want to scroll down and install one of these. So either one's fine. I'm just going to go with the first one. And it's going to look like you have to log in or sign up, but actually you can just click this no thanks, start my download. Click that. Yes. Make sure you read this delicious novel. It's very awesome. So intense. Now I'm going to go custom on this one. Under this one, I'm going to add the server itself, and we're going to go with the 64-bit one. And then under applications, I'm going to go with MySQL Workbench. There's a bunch of other stuff you might want to download. If you're not really sure, you can just install the full package. For example, if you want to work with C++ or .NET, you might want to install some of these things. But honestly, this is all I'm going to need. If you're unsure, I would go back and click the full installation. But I'm trying to save as much space as possible, so let's go with this for now. Execute. All right, next. Next. All right, this stuff's important. What kind of machine are you going to be using? I'm going with development. TCP IP, port number. This is important. If you have something running on this port, you can have conflicts. That's probably good. We can click advanced if we really want, but that sounds scary, so let's not. Next. Now we need to set a password. Now this is for what's known as the root account. It's kind of like the super admin administrator. So if this is a production environment, you want to make sure you have a very secure password. And you can actually create user accounts that are allowed to do other certain things. Now obviously, this situation, I'm going to go with the root account because why not? This is my machine and this is just for learning. So let's go with root. Now it starts talking about services. And services are applications that run in the background when your computer is running. You can find those by going to your start menu and typing in services. Here is a huge list of services that are running on my machine. This is talking about configuring MySQL as a service. So I'm going to have it to where I'm running MySQL as a service and it's going to start up automatically when I turn my computer on. Oh, come on, Claire. This one's fine here, so let's click next. Now this page talks about all these extra features you can enable by checking this box. I decided I'm going to check that. And now we are finally ready to finish this whole process. Now I'm going to check private networks and uncheck public networks. And there we go, we have MySQL installed. Now how do we actually use this? Well, if you go to your start menu and go to all apps, you can scroll down to the M's and find MySQL. And inside of here, we are going to have MySQL Workbench and the command line client. We'll be talking about MySQL Workbench in upcoming videos, but just for fun, let's start with the command line client. Now when this pops up, it's going to ask for your root user account password. And I'm just going to type mine in. And now we can start writing our SQL commands. So I'm just going to start with select 5 times 5. And if you press enter, it'll keep going down to the next line. That's because you have to put what's known as a delimiter, which in this case is a semicolon. There you go. We just wrote our first select statement. So that's that, guys. Hopefully that was enough information to keep your brain working for the next few minutes. We'll be continuing and we'll finally start learning about different SQL commands. If you like this video, please be sure to click like, subscribe, and as always, continue on to the next video. Thanks, guys. See you then. Welcome back, everyone, to Caleb the Video Maker 2. That's my new official theme song. So this is where we left off in the command line, but I don't really want to use the command line. So we're going to learn a new tool called MySQL Workbench. So to open that, you need to go to your start menu, and I know mine's cut off a little bit, but that's okay. And you can just search Workbench. Now when you open this, there's already something listed here, and this is the default connection, your local host. That's exactly what we want to use, so it's nice that it already has that there for us. But we can add connections clicking this little plus button, and you can type in all the information you want. But for us, we're gonna go with this local host, so double click that, and it's going to bug us for a password. Now this is the password that you gave when you installed MySQL. If you have no clue what I'm talking about, go watch the previous video. And then I'm going to click Save Password and Vault. You know, because I want to make sure I'm using the most powerful account and have the password saved so that anyone can go in and delete my stuff. No, but in all reality, this is a development environment. I don't really want to have to worry about forgetting my password and all that junk. So let's click OK, and voila, it opens up our database server. So just like in the command prompt, we can type in SQL, well, we can do that here. So we could say select 5 times 5, and then execute it. And you can see it returns 25. So that's how you run SQL commands inside of MySQL Workbench. There's a lot of stuff you can do to customize the view here. For example, there's these buttons over here you can press. And as you can see, that makes things happen, and you can hide stuff. There's also this button up here, View. And you can go to panels and basically do the same thing. I'm going to enable all of those just so we can see everything. And if you look down here over on the left, you can see here are our schemas. So it's kind of hard to see, so we have to drag this down a little bit. But essentially this is going to be our databases. So here is a database and it has these tables in it. So when we create a new database, it'll come down here. One interesting thing you can do is press this little button here, and essentially what that's going to do is hide all of this other junk. So let's click that, and you can see it's all gone. Boom. And if you need to see it again, you can click it again, and there you go. Also, when you click that, you can go down here and click this button to get to the other tabs. So for example, we can click this button here, and it will bring back the schemas. That's kind of useful because a lot of this junk I don't really care about right now, so I'm going to maximize that and just keep it like that. Now, if you need to go back to the home page that opened when we first started, you can go up here and click this little house, and there you go. MySQL Workbench is a very popular program for designing databases. So to do that, you can go down here to the model section and click plus, or you can dork around with the one they already have on there. One thing that might come in useful for you is this MySQL utilities thing. I never actually installed that, but you can download that. That'll give you some extra stuff you can do with MySQL, but we're not going to need that for now, so I'm not going to download that. So yeah, guys, that is a very rough intro to MySQL Workbench. Now, I actually have an entire video over MySQL Workbench that I went into detail on how to do different things and design databases, and you can watch that if you want. Just check it out. Oh, God. Claire! Sorry, guys. There's a stalker on the loose. Anyways, you can check that out if you want, or you can just go through the series and we'll be covering some of that information in this series. So thanks, guys. Hopefully this worked out for you. If you have any comments, please leave them below. Click like if this video is helpful. And as always, I will see you in the next video. Be sure to subscribe. Oh, it's still recording. Hey, what's up everyone? Welcome back to your MySQL tutorial series. Now, as we go through this series, I'm going to be throwing words at you and key terms, and if you don't know what these terms are, you're going to get lost. That's because when you start with databases, there is a ton of terms that you need to become familiar with. And if you're not going to be able to keep up with the important information where those terms are considered prerequisites. Because of that, I'm taking a couple videos just to talk about terms and go through them all, so that way we're clear on what is what. So the very first term is data. Now data, my friend, is just information. Don't make it too technical or fancy or, data. Oh, we collect data. It's fancy. But really, it's just information. When you take a bunch of information and put it all together, you get what's known as a database. So data gets put into a database. Now, how do we work with this data? We need something known as a database management system. This is essentially a software that allows us to work with all of this data. Now, MySQL is an example of a database management system. Now, if you took every single database management system, a subset of those would be called relational database management systems. So think, this circle represents database management systems. Inside of that, we have relational database management systems. Now, MySQL is also an example of a relational database management system. So if we had MySQL right here, not only is it a relational database management system, but it's just a general database management system. And that's pretty clear from the name because they both have DBMS in the title. But not all databases are relational database management systems. We still have all of these databases over here. But what's the difference? Well, we're not going to focus a whole lot on these databases right now, but these ones, they are what's known as relational. And all that means is that they present our data in tables. A really cool word for table is relation. Now, what is a table? You can think of a square, and within the square you have what's known as columns. Columns are the headers of the table. The table will also have a name. So we could say this is the membership table. Then the columns are going to list the data we want to store about memberships. We are essentially going to make a table that lists possible memberships for a gym or for a website or anything like that. So we might have, an ID, a title, and then a price. So that's what the columns of this table are. ID, title, and price. Now the other term you need to know is row. Rows are data that we put in to match these columns, but we give actual data, not just categories of data. So we give an actual ID, we give an actual title, and we give an actual price. So for example, we could have the ID of 1, the title could be silver, and the price could be $30 or 30 whatever. That is an example of a row, and we often have multiple rows inside of a table. You can think of the rows as instances of whatever the table is describing. So each row is an example of a membership, and the data it has is the ID, title, and price. You'll often hear a couple of other terms when we're talking about tables. One of those terms is a record. A record is just another name for a row. You'll also hear the term field, which that usually describes one value inside of a column. Or you could also call it a cell. Now some people, when you say field, they think of the whole column. So that can get a little confusing, so I'm not going to use that term a whole lot. But I will use record, and I'll also use the term entry, which is the same thing. You can just think of entering this data as an entry inside of this table. Now when we have a table, sometimes it is appropriate to leave some information out. In this table, we don't really have a good column that we can do this for, but let's just go through it and see what that would look like. We could have another membership with the ID of 4 and the price of $200. But the title has no value. As you can see, it doesn't make a whole lot of sense in this membership table because it's important that every membership has a title. But if we had a column such as description, it might make sense to leave some of these blank. So we could say this is the ultimate title, but we could leave the description empty. In this situation, you could say this is a null. A null is just an absence of a value. So continuing our list, I'm going to put that down here. Sometimes that's appropriate, sometimes that's not. It's often a decision you have to make. Does it make sense for this to be null, or should we force every single row to have a value for this column? All of these things are part of what's known as database design. Database design makes us ask questions like, what tables do I need? What columns do I put in that table? Do I allow them to be null, or do I force them all to have a value? How are these tables connected to one another? How do I enforce the way they're connected? All of that information. Essentially, database design is all about what's known as data integrity. That is actually the term we are going to start with in the upcoming video. So you guys better go check that out. Hopefully all this information was helpful. Thank you for watching. Please be sure to subscribe, click like, and as always, I'll see you in the next video. Thanks, guys. Hey, what's up everyone? Welcome back to your MySQL tutorial series. I'm Caleb from Caleb the Video Maker 2. In this video we are going to be continuing our discussion on database terminology. Two terms you need to be familiar with are entity and attribute. An entity is just a thing we store data about. Attributes are the things we store about that entity. Now I'm going to continually bring up the concept of data integrity. Data integrity means that the attributes we are storing about the entity are accurate, as up to date as possible, not redundant, meaning duplicates, and there's no conflicting information. There is a lot of stuff we do inside of a database to enforce data integrity. It's one of the most important things to have when it comes to database development and database design. So if we have an entity and we have a couple attributes that describe this entity, let's say we have another entity, so two instances of an entity. Let's just say these are users, and each one of these is an attribute that describes the user. What if, by chance, this matched this matched this, and this matched this? It would almost be as if we had duplicate data. That's because both of these would look like the same thing. That's because all of the attributes about it are the same. So we could have like the first name, last name, and email, for example. And we have two users with the same first name, last name, and email. That's confusing. How do we prevent this? Well, we need to introduce something known as a primary key. Now, a primary key is something that is unique and not null. So for example, if this third one was the email, right? We could make this the primary key, And if that was the case, we would be able to distinguish these users because we would force the email to be unique. And that would mean two users couldn't use the same email. This is an example of a natural key. That's because the key is something natural. It's the email. It's something that exists in the real world. Another type of key is a surrogate key. A surrogate key is just a value that's generated by the database, generally an ID. So we could say this user has the ID of 7 and this user down here has the ID of 8. We can use that to distinguish the two different users. That way we know that there's actually two users and not one user entered into the database twice. That's because we have this to distinguish it, the ID. Now what do you do if you want to reference this primary key in another table? Or if you want to reference another column? For example, we might have a comment table. And this comment table might reference a user. How do you do that? That introduces the concept of a foreign key, and that's the word we will start with in the next video. Thanks guys for watching. Hopefully that was helpful. As always, I ask that you please click subscribe to support this channel, and if you like this video, give it a like. I will see you in the next video. Welcome back everyone. It is Caleb from Caleb the Video Maker 2, and this is your MySQL tutorial series. We are going to continue our discussion of beginner terms, and the term we're going to start with is the foreign key. A foreign key is a column that references another column in another table. Often this will point back to a primary key. It does not have to reference a primary key. It could reference a unique column. Essentially, it's just a way to reference another entity, and that entity has to be labeled unique, or else it's not going to know which entity you want to reference. For example, if you have these two people and you want to reference the person from over here somewhere, how do you tell it which one you want to reference? There has to be a way to uniquely describe these people. So often it'll be an ID. And then you could say, oh, the person with the ID of 7 is being referenced in this row. All of these rules, including primary key, unique, and foreign key, these are all known as constraints. Constraints are something that are very important to protect our data integrity. That's because they force relationships to hold true. If we didn't use constraints, we could still use the value 7 over here, but we're going to get rid of this reference. And that means if this person gets deleted or something, that this 7 is no longer meaningful for anything. In that situation, our data would be outdated. We don't want that. That would violate data integrity rules. So to force those integrity rules, we use constraints. Another way that we force integrity is using data types. That's pretty bad. MySQL has a plethora of data types, and we are going to discuss many of them in upcoming videos. Every column is going to have a data type. That way the database knows how to interpret that data. The way the database works with data depends on the data type. One area where this is important is if we have a numeric column. That means numbers, and we try to store a string in there, that's not going to work. And by that not working, we are taking another step to protecting our data integrity. So this here would be a string value, and we are trying to store that in a numeric column. That's not going to work. There is one situation where you need to be extra careful with the data type that you give a column. When you have a foreign key, or right here, and it references a primary key, these both have to be the same data type. That's super important. If you're having problems creating foreign keys, that might be part of the problem. The primary key might be a different data type than what you were trying to make the foreign key. One other keyword I got for you is index. You can tell the database to index important columns, and in fact, it's going to index certain columns automatically. Primary keys are automatically indexed. Unique columns are automatically indexed. Foreign keys, on the other hand, are not automatically indexed, but oftentimes you will want to manually index them because we use them so much. What an index does is increase the speed that we can work with these columns. So when we are doing a select statement, if we are selecting the columns that are part of an index, we are going to have a much faster query. Now the last thing I got for you guys is that when you have a foreign key referencing a primary key or a unique column, this is known as a relationship. And that is what we will be discussing in the next video. So thank you guys for watching. Hopefully this was helpful. As always, please click subscribe if you want to support this channel, and if you've enjoyed this video, please click like. If you guys got any suggestions at all, leave a comment and maybe I can make a video about it. Thanks guys, and I will see you in the next video. Hey everyone, welcome back to your MySQL series. We are going to be moving on to one of my favorite topics, relationships. Relationships are created when we have a column that references another column in a database. This is what's known as a foreign key. A column is a foreign key if it references another column. And the column it references has to be either a primary key or have the unique attribute. When we do this, we create a relationship. This is a relationship because we have multiple tables and they are related in some way. In somehow, really? Now there are actually 3 types of relationships. Now we can only store these 2 in a database. This one we actually have to manipulate into, you guys want to know about that? I'll make you wait till we start talking about many-to-many relationships in the upcoming video. In the meantime, we are going to focus on one-to-one relationships. One-to-one relationships are actually very easy to understand. All it is an attribute that describes an entity. Now, if you don't remember what attribute and entity is, go watch the previous videos where I talk about terminology for databases, because that's all foundational to what we're talking about here. An example of this might be a user and a username. In this situation, the username is the attribute that describes the user. And then if you want to get more specific, we could give an example of a user and a username. So here's a user, and his username might be Caleb123. That specific username exclusively describes that specific user. If we have this other guy over here, he's not going to get that sweet name. He's going to have to come up with something on his own. Good luck though, because you cannot compete with Caleb123. Now that we understand that a one-to-one relationship is simply an attribute that describes an entity, how do we store this? Well, how do we normally store attributes? It's simple. We just store it as a column inside of a table. The table is designated for that entity. So we would have like a user table, and one of the columns would be whatever the attribute is. In this case, the username. So we could have a user with the ID of 7 and the username Caleb123. You're not limited to just doing this over one table. You can have one-to-one relationships over different tables. You just have to remember that you need to use the unique constraint. So if we had another table over here, we could reference the user ID, for example, and then what we would do is label this as unique, and that means this column is exclusive in that each row references only one ID. For example, 7. We could not have another 7. That would be against the rules. So that kind of sums up how to design one-to-one relationships. You either have it as a column inside of a table that describes that entity. The user table would be that entity right here, and the column would be the attribute describing that entity. Or you can have it over multiple tables. You just have to remember you need to use the unique constraint to force a one-to-one relationship. If you don't use the unique constraint, you create what's known as a one-to-many relationship, which we will talk about in the next video. So that's all for this. Thank you guys for watching. As always, please support the channel by clicking that subscribe button and clicking like. That really helps me grow my channel, and yeah, that's about it. So thanks. Peace. What's up, everyone? This is Caleb from Caleb's Video Maker 2, and we are going to continue our discussion on relationships. We are going to be discussing one-to-many relationships. Yeah. We briefly discussed one-to-many relationships in your last MySQL video. And really, the concept is not that hard. All it is when there is a foreign key that references another column. To learn about one-to-many relationships, let's go through a simple example. Let's say we have a bidding website like eBay. I didn't say it. Where you can post stuff on there and people can bid on it to buy it. Now, the business rules of this application are that a user can create an account and they can create as many listings as they want, but one listing is owned by only one user. So you get this kind of setup. This is how you would draw a one-to-many relationship if you had to draw how everything was connected. That's because one user can have multiple listings, but a specific listing is not allowed to be owned by multiple users. So this situation is okay, but this is not okay because now this listing is owned by this user and this user. That's not okay. So we're just going to erase that. When you have this kind of setup, the thing that is being referenced multiple times is going to be put in its own table. So you would literally just create a listings table. It's pretty simple. This listings table is going to have a foreign key column that references the user. So let's draw this out with some actual data. That way it's a little bit more concrete. Here we have the users table. We'll keep it simple. We'll just have ID, first name, and last name. Here we have a users table, and I've conveniently pre-inserted some data for us to use. So we have 3 people, Caleb, Amy, and George, and these are the users that are going to create listings on our bidding website. So this will become our listings table, and the columns will be the ID, and then a reference to the user ID, and then we can just say title, for example. If we wanted to get really in-depth with our bidding website, we could have a description and quality and all of that good stuff, but this is plenty for now. So let's put some data in here. We'll give the first one an ID of 1, and then we'll give it a title of pizza rolls, and now we just need to give it a user ID. Now the thing with database design is that we try to keep everything atomic. If you haven't heard of that word, it essentially means the smallest indivisible piece that still makes sense. So a user ID, we only want 1. We don't want to have 2 user IDs, and we don't want to have a half a user ID. And we only want to store user IDs in this column. We don't want to store user IDs and the user's name or anything like that. Everything has to be atomic, the smallest piece that makes sense. So in this situation, the column is atomic. That's because we're only storing one thing in this column, the user ID. But now the rows have to be atomic too. They only store one value for each column. So we already have one value for the ID, we have one value for the title, and we have one value for the user ID, and we'll make that 9. That was a hard choice. Now if we wanted to have a one-to-one relationship, all we would do is make this user ID column unique. That would force every single row to be unique, so a user could only have one listing. But we don't want to do that. We want it so that a user can have multiple listings. So we don't make this unique. Now we can have another item by the same person, and we can say this is, give me a weird item, hurry, Slinkies. I don't know how to spell Slinkies. Now you can see we have 2 rows that point to one user, but we don't have any rows that point to 2 users. In fact, it's not even possible with this setup if we're following our atomic rules. Only one user ID can be given for a single item. So this is how you properly design a one-to-many relationship. It's very similar to storing a one-to-one relationship across multiple tables. The only difference is you do not use the unique keyword. We can also have other data in here. For example, we could have another item by the ID of 8, and it could be, give me an item, hurry, dog treats, yum. And that would reference one individual user. So yeah, guys, that's how you design one-to-many relationships. Hopefully that was nice, crispy, and crispy. No, not crispy. I don't know what I was trying to say. Probably like crystal clear, maybe? Yeah, hopefully that was nice and crispy for you guys. I will see you in the next video. And as always, if you've enjoyed this, please click subscribe and give this video a like. Thank you so much, and I'll see you in the next one. Hey, welcome back everyone to your MySQL tutorial series. I'm Caleb from Caleb the Video Maker 2, and this video is going to be about many-to-many relationships. Now, I highly recommend you watch the previous video, which is one-to-many relationships, because this video is going to build off of that video a little bit. The reason I'm telling you that is because this is the exact same setup we had in the last video, and I'll describe this just a little bit. Essentially, we're trying to make a website where you can make auctions and people can buy stuff, right? So we have listings, and a user can post as many listings as they want, but one listing can only be listed by one person. So for example, this specific listing is only allowed to be owned by the user with the ID of 9, or the user with the ID of 10, or 11, but not more than one, only one. If you think of some popular auctioning websites, it's generally considered normal that an item being sold is owned by only one person. Now there might be a couple out there where you can joint ownership something or joint list something, meaning this item could reference two people, for example. In that situation, there's kind of like a co-ownership, meaning when the item's sold, the revenue earned is split amongst people. That might not be common on an auctioning website, but it might be common on a website where you sell courses or something along the line of that, because a course might be authored by multiple people and the authors might split the revenue. So this might not apply directly to an auctioning site, but ultimately that decision is up to you or the business telling you to design this thing. That's because if you want to make an auctioning website where you can have multiple people own a single item, you go ahead and do that. It's your website, it's your application. There's not rules saying you can't do that. So that being said, that's what we are going to do in this situation. We are going to make it to where a specific listing can be owned by multiple people. Right now we have it set up as a one-to-many relationship. But as you can see, we're talking about many-to-many, so we need to alter this a little bit. Now I want you guys to think about this really hard. If you're going to try to force a listing to be owned by multiple users, you're going to run into some serious database design problems. How would you even go about doing that? Let's think of some ways. Let's go with the pizza rolls. We could throw in another user in here. We could add a comma and throw in the user with the ID of 8. But this is going to break our atomicity or atomic rule. Now we have two values for one column. That is not okay. So you might think, let's add another row. So now we have the same item with a different user ID. But there's a problem here in that we have a repeating primary key, which is not acceptable. The other problem we are going to have is that now we have this pizza rolls in here twice, and that's redundant. Now this column is probably not marked as unique. If it was, then we couldn't even do this. But the chances are it's not, so therefore we're just going to have duplicate data. And just by chance, let's say we could do this, and one time this was updated, this one might not get updated, and then we have conflicting data. So bad design like this leads to conflicting data, and that's really bad. Nearly any time you have a problem like this, the solution is to add a table. I know it sounds like it could cause problems just adding tons of tables, but I'm serious. So let's add a table and see if it works. What kind of table are we going to need? The table is called an intermediary table. And this table is going to go between these tables and just be like, whooshah, and it's going to separate them. This is going to allow us to store a many-to-many relationship in a database. So what we are going to do is put a new table here that's going to be in between the users and the listings. Now this table, by convention, is going to have the first table singular, so user underscore the second table plural, listings. And this is going to make associations from the users to the listings. So the only columns we really need in here are the user ID and the listing ID. Now let's fix up this crap. First, let's get rid of that row. We don't want that at all. And then I'll put this up here so we know that we want to put two of those over here. So the first one, let's just go row by row and we'll show how to convert this data. Now obviously you're going to want to design this right from the beginning so that way you don't have to move data from tables to tables. That's just bad. So the first thing, we're going to grab the listing ID 1 and associate that with some user. Let's go with 9. Now you can see this is going to allow us to have multiple users because we can just add a new row and have the same listing ID and a different user ID. Now these columns are not labeled unique, but actually the whole combination of both of the columns can be labeled unique. That means we can have 9-1 and 8-1, but we can't have 9-1 again, because that would mean both of these as a group are not unique. So that means in this table we can just get rid of this. And then let's add another row. We'll have 2, user 9, 3, and user 8. As you can see, we're not going to need to store the user in here anymore because all of that information is found in the user listings table. So we can just get rid of this entire column. Now let's draw lines just to show how these are connected, and that will help us visualize this. So 8 goes to 8, and to 8. And then 9 goes to 9, and 9. Then on this side, 1 goes to 1, 2 to 2, and 3 to 3. Now this will help you visualize how we broke up this many-to-many relationship. We actually broke it up into two one-to-many relationships. For example, look at this ID. On this side we have one ID that's referenced twice. And it kind of goes in multiple directions this way, like this. And that is actually how you draw a one-to-many relationship when you're designing tables. It'll look something like that, except prettier. You will never have it where you have an ID breaking off like this. Because you can see here now, it's backwards. And we have many-to-many. Again, so that will never happen. We fixed the problem of many-to-many by breaking it up. So this is a pretty good summary of how you design a many-to-many relationship. You just need to break things up into 3 tables. In the next video, we are kind of going to conclude all of the relationship stuff and just go over a quick overview of how to design each relationship. Thanks guys, hopefully this is helpful. If you enjoyed it, please click like, and as always, click subscribe, and I will see you in the next video. Welcome back everyone to your MySQL tutorial series. My name's Caleb from Caleb the Video Maker 2, and in this video we are going to be summarizing our discussion on relationships. Now I'm not going to do a whole lot of drawing just because I wanted to talk about it. I want you to understand conceptually what you need to do when you have one of these 3 relationships. And you will always have one of these 3 relationships when you're storing data in a database. If you don't remember all of the specific details, that's okay. You can always come back to these videos and watch it. But I want you to think through this. Try to memorize the content of this video because I'm not going to give you any specifics. This is going to be a rough overview and a rough summary. So the very first one we talked about was a one-to-one relationship. This is an attribute that describes an entity, and you can just store it in the same table. You don't have to create a whole nother table for it. You can though if you want that separation for some reason. For example, if you want some data of the user stored in a different table, that's fine. The only thing you're going to need to remember is to mark the foreign key as unique. That's because we don't want to have multiple entries relating back to one entity. That would break the rules of one-to-one, and that is actually how you set up a one-to-many relationship. In a one-to-many relationship, you can store as many rows as you want referencing back to a single entity, and that foreign key is not going to be labeled unique. The parent table, that's the table being referenced, doesn't need to know about this other table. You don't have to put any foreign keys in that table. That other table doesn't exist. It's just alone by itself, but that table that references it knows of the parent table. So the foreign keys reference the table, but there's nothing in the other table to reference it back. There is a layer of separation, and you can do that to separate one-to-one relationships like that, or you can do it to make one-to-many relationships. Now the third option is many-to-many relationships. And we actually can't store these in databases very easily, so the way we do it is to break it up into 2 one-to-many relationships. In this situation, you are going to need 3 tables. One to store one entity, one to store the other entity, and then an intermediary table to kind of break that many-to-many tension between the 2 tables. So kind of think of like the 2 tables fighting because they're both trying to reference each other and they want to be the one, I don't know. Imagine them just kind of trying to reference each other and one wants to be in the lead or something like that. Something to imagine conflict. And then this intermediary table steps in, cuts that tension in half, and separates the 2 entities and fixes all the problems. In that situation, you are going to have one-to-many relationship facing this way and a one-to-many relationship facing this way. Now inside of that intermediary table, the combination of the 2 IDs or the foreign keys are going to be unique. That means the entity over here can be in there multiple times and the entity over here can be in there multiple times, but not the combination at the same time multiple times. That's because it's an association. If you associate a row from over here and a row from over here, they're already associated. You don't need to associate them multiple times. That would not make sense. You can actually use the combination of the 2 IDs as the primary key. So in summary, one-to-one is just 1 table. One-to-many is 2 tables, and many-to-many is 3 tables. Hopefully that was helpful, guys. Please be sure to click like if you've enjoyed this video, and click subscribe if you want to support this channel. And as always, go check out the next video because that's when we're going to introduce a new topic, and that's going to be great. So I'll see you then. Welcome back everyone to your MySQL tutorial series. I'm Caleb from Caleb the Video Maker 2, and in this video we are going to start talking about data integrity. Now there are three categories of data integrity. We have entity integrity, referential integrity, and domain integrity. Each one of these is going to get its own video. So this video is going to talk about entity integrity. Entity integrity is very simple. All it says is that every table needs a primary key. When you label something a primary key, it's automatically going to be unique and not null. Sorry, my dog is feasting right now, so if you hear nom, 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 nom in the background, it's him. I apologize, he could not be stopped. In addition to this, a primary key should never change. These are the three things that need to happen for something to be a primary key. Now there's actually two classifications of primary keys: surrogate keys and natural keys. Surrogate keys are simple. They're just computer-generated numbers that have no real-world meaning. So this is often the ID column in a table. Natural keys, on the other hand, are a little bit harder to work with because these have to have real-world meaning, such as a username or an email or anything that can be unique. Okay, Onyx, quit licking the floor. Now this is not something we tell the database. We don't say, yo database, this is a surrogate key or this is a natural key. Onyx, drink water, drink it. Drink your water. These are just terms for us to help understand the different kinds of keys. And these are terms people are going to use, so you need to understand them. Why is having a key so important? Well, if you have a table, and it doesn't matter what the columns are, let's just say that's a row. And then we have another row, and you can see this is duplicate data. And this brings up the question, do we have 1, 2 entries that are supposed to be different, or is this the same entry in there twice? It's kind of confusing. But if we have a primary key, we can always assume that they're two different things. So for example, if we have here 8 and 9, and this would be like the ID, we know that this describes an entity and this describes an entity. So these are unique. Check. They're not null because every single one has a value, and it has to never change. Let's see what would happen if it did change. Let's say this changed to 19. Now we're confused because it was 9 and now it's 19. So does this 19 refer to a new entity or the same entity with a new ID? It's confusing. If we were following the rules of primary keys and that they never change, I would assume that it's a new entity. And since people assume that, we don't want to change our primary keys ever. So if you're using a natural key, you gotta make sure it's something that's not going to change. And that's kind of hard to figure out. Like an email, that's pretty good because it might not change, but what if someone wants to change their email? Well, then they have to change their account information, and then it's no longer a very good primary key. So you'd have to restrict people to not being able to update their email. Well, a username might work because in that situation, it's not going to change. You can restrict people from updating their username. That's just for like a user table example, but you're gonna have those kind of problems with any table that you use natural keys. Because of that, I think more people are starting to use surrogate keys. Are surrogate keys better? I don't know, that's up to you. There's downsides and upsides to using either one. For example, natural keys are much more readable. Instead of having this number here, we could have a string that actually has a value in it. And this allows you to do less joins, which we haven't really discussed, but essentially when you have multiple tables and you want to get data from both of these tables, you have to join them. Natural keys allow you to use less joins. But in general, I'm probably going to go with surrogate keys. I think they're easier to work with and I think they're more common. If you want to use natural keys, I'm totally cool with that. Just make sure that they're unique, not null, and they never change. Never. So yeah, everyone, that's your introduction to entity integrity. If you've enjoyed this video, please click like and subscribe. And as always, I will see you in the next one. Woo! Hey everyone, welcome back to your MySQL tutorial series. I'm Caleb from Caleb the Video Maker 2. This video is going to be discussing referential integrity. This has to do with foreign keys referencing other columns. So when we have a foreign key, we could say it's a reference to another column. And we need to protect our references' integrity. What does that mean though? It means we have to tell the database that this is a foreign key. So this is something we have to explicitly do, meaning there's no conventions that go on that automatically connect columns or anything like that. Any kind of connection across tables or across columns, we have to tell the database explicitly. If you don't tell the database, you might think that's fine. We can just pretend there's a connection, right? Let's say you don't want to use foreign keys for some reason. So you have this number over here, this ID, for example, and then you reference that ID. But you don't tell the database that there's a reference, then these are separated. You can't draw the line between the two. And what that means is that there's no restrictions on the data you're allowed to use. So for example, I could make a reference to 198, and even though there's not a 198 over here, that's okay. That's because the database doesn't know any better. To the database, it's just a number. It also means we could just get rid of this row, and the database isn't going to care. This 37 is still going to exist over here. This throws our references integrity into question, because we can have a reference, but we don't know if it actually points to anything. For example, this one, it points nowhere. So how are we supposed to know which ones point somewhere and which ones don't point anywhere? That's what I'm talking about with integrity. If you don't have data integrity, you can't trust your own data. And if you can't trust your own data, your database is not worth anything. That might be a little harsh, but seriously, get your data integrity. We need to tell the database explicitly using the foreign key constraint. We'll get into the syntax on how to do all that soon, but just know for now that when there is some kind of reference, you have to do it manually. You have to tell the database what column from what table you are referencing. In addition to just telling it what is referencing what, you can do stuff such as on delete and on update. Essentially what these mean is what happens if we delete the parent or change the parent to a different ID, which by the way should never happen, but in theory, let's say it happens. These are things you can configure with your foreign key constraint, and we'll get into how to do all of that in an upcoming video. But for now, I think that's good. I'm sure you guys understand what referential integrity is. It's when your reference can be trusted. You know it references something, you know it's up to date, and you know it's referencing the correct thing. That's what we strive for. It's impossible to have perfect integrity in a database, but we can get pretty darn close. So that's what we're going for. Thank you guys. If you like this video, please click subscribe and like. And as always, I will see you in the next video. Yeah! Oh! Hey, welcome back everyone. It is Caleb from Caleb the Video Maker 2. And in this video, we are going to be talking about domain integrity. Now, I'm fairly confident in you guys. What we've studied about MySQL is probably enough to where you already have domain integrity. The reason I'm making this video is so that we cover all the details of integrity, for one, and for two, when someone says domain integrity, you're not like, duh, I don't know what you're talking about. Just because you might understand all the pieces of domain integrity doesn't mean you understand that those pieces build domain integrity, if that makes any sense at all. So once we start talking about it, it might make a little bit more sense. Domain integrity is essentially when our data fits what is appropriate or what is expected for a certain column. This requires us to define what's allowed and what's not allowed. That whole concept is known as domain. The proper data inside of a column contributes to domain integrity. So if we have a column and we're expecting a phone number, we want to make sure all of that data in that table for that column stores a phone number, not just random text or a few numbers but not the whole thing. We want to ensure that the data is as close as possible to what's expected. So the domain establishes what's not allowed and what is allowed. So we want to make sure all of our data fits inside of here and it doesn't go too far this way or too far that way. This might make sense with numbers, like not too low or not too high, but I'm just kind of drawing this generally. We got to make sure we fit within the rules. So we don't want to make something too long, we don't want to make it too short, we don't want to make it too high, we don't want to make it too low, everything like that. So another way to think about it is this entire thing would be the possible values, but we are only going to accept some of the values inside of this area right here. That is domain. Now with MySQL, there are a few ways we can enforce domain. The first is with a data type. This is by far the easiest way to get some level of domain on a column. That's because if you have something such as a numeric data type, that's automatically going to reject strings like string. That's because this is not a number, it's a string. It doesn't go inside of a numeric column. So data type is one way. Obviously the two constraints we talked about, not null and unique. These can also be used to help with the domain integrity because we can force every single row to have a value or for every single row to have a unique value. That further restricts the data. All of these are the simple way of protecting our domain. Now, some database management systems have what's known as a check constraint, and these things are pretty cool, but unfortunately MySQL does not have these. That's when you can say something like, we want a value to be between 5 and 50, for example. There are ways to mimic this in MySQL, but that requires more advanced MySQL knowledge, so we're not going to dive into that right away. That means if we want to be very specific on what's allowed, like if we want to say, oh, just this data, so we could say something like any phone numbers that fit a certain format. That's all going to have to be done with advanced MySQL or application logic. What does that mean though? Imagine a website, right? And you're signing up and you have to put in an email. And you just put some garbage in there that's not an email, clearly. Well, you can do things to make sure that that data is an email. For one, on the client side, you can make the input an email, which with HTML5, that's already going to bark at you and tell you you're doing it wrong. Then, even if someone bypasses that by modifying the HTML, we can have server-side code, such as PHP, check the data and see, is this really an email? And if it is, then we can store it into the database. If it's not, we can return an error. So all of that goes outside of the database, into the application. It's a separate thing, but just know that we can restrict data to be very specific. Not so easily with MySQL, although it is possible. So thank you guys. Hopefully this was a good overview of domain integrity. Obviously, we're not supposed to dive in and conquer the whole concept of domain integrity. We're not going to get into this stuff or how to mimic check constraints in MySQL for a long time. So let's start slow. Let's go with this. Hopefully that was helpful. And as always, I will see you in the next video. Also, one more thing. If you guys want to support this channel, please click subscribe and like this video. Thanks, guys. See you in the next one. Guys, look. There's deer in my yard. What's up, everyone? It's Caleb from Caleb the Video Maker 2. Welcome back to your MySQL tutorial series. This video we are going to discuss primary keys. And we've had some primary key information kind of sprinkled throughout the series, but we never actually devoted an entire video or two to just primary keys. I think this is going to be useful because it's going to take all those chunks and kind of piece them together so you can get the big picture of primary keys. So let's discuss primary keys. What are they? A primary key allows us to uniquely talk about an individual entity or a row. So imagine we have a table and we just have, millions upon millions of rows, and we want to talk about a very specific row, one row out of millions. How do we do that? Well, the primary key makes this very simple because it allows every single row to have a unique identifier or an ID. An ID is essentially a number that's generated by the database. It doesn't mean anything in the real world, but it allows us to uniquely talk about a specific row. So imagine you're walking down the road and some guy comes up to you and he's like, bro, can you give me information on the user in your users table for your database? Because, databases are forgetting data, so this is a potentially real situation in the future. And you're like, wait, which user are you talking about? And he starts describing him. He's like, oh yeah, he created his account somewhere in January or February. And he's a premium member and, all these criteria. And essentially what you do is you start searching through your table and getting rid of anything that doesn't match that criteria. So you get rid of all the users that didn't create an account in January or February. You get rid of the ones that don't meet any of the other criteria. But you're still left with like a couple hundred users, and you can't talk about that individual user because you can't define that individual user. Wouldn't it be a lot easier if that guy came up to you and he was like, psst, give me some information on the user with the user ID of 3072. And then you'd be like, oh, okay, well this username has this and this and this. It allows you to uniquely identify that user. That's just one example. You can use IDs for other types of tables. It's not always a user table. Almost every table you work with is going to have an ID. And if it doesn't have an ID, it's going to have something to uniquely define it. The ID is known as a surrogate key. That is different than a natural key. A natural key is actually used for something. So it could have came up to you and said, hey, give me information on the user with the username of whatever the username is. And as long as that username is unique, it would work. So what do we need in order for a primary key to work the way it's supposed to work? Obviously it has to be unique, like I just said. So the data has to be unique. In addition to this, it has to be not null. That means every single row has to have a value. Finally, the data should never change. Now these two are pretty easy to enforce with MySQL because these are constraints. You can literally just say unique right after the column definition when we're creating a table. Same with not null. Unfortunately, the whole concept of the thing never changing is not quite as easy. In order to help the data never change, it's helpful to use either an ID or a natural key that is not likely to change. For example, an ID will never change because why would it? The only use is for the database. There's not going to be a situation where the user asks to change their user ID. That's because they don't even know what their user ID is. A username could be a natural key, and that might be a good one to use because the chances are you could restrict users from changing their username and they'll be fine with that. That would work as a natural key and it probably will never change. So it's pretty simple to think of a natural key for a user table, but when we start creating other tables, it might get kind of complex and complicated trying to figure out what do we need to force every single row to be unique. That's why I think more people are moving towards surrogate keys. I think they're more commonly used because they're just easier to work with. That's because these three things are automatically very easy to get. These two can be easily enforced, and the data changing is not likely. Now when you actually insert data into your table, and you have a primary key that is an ID, every single row is going to have a different value. So you might have 1, 2, 3, 4, and you might get annoyed with having to figure out what's the next number. Fortunately, MySQL has a very easy way to figure this out and get this to work, and that's by labeling that column as auto increment. Kinda ran out of room here, but that's okay. I think actually that's where I'm going to start talking about in the next video. That's just because I don't want this video to run too long and bombard you with too much information. So be sure to check out the next video where I'll discuss auto increment and a couple of other things. So thanks guys, and I'll see you in the next video. Welcome back everyone to Caleb the Video Maker 2. This video we are going to be talking about the auto increment attribute. Now I mentioned the word attribute, and these are the things we put after the column when we create our table. So we might have something like user ID, and then we could say primary key, and then add auto increment. These are both examples of attributes, and this would all be inside of a create table, which we'll discuss create table in detail in an upcoming video. So let's not get distracted, just know that auto increment is an example of an attribute. Now what is auto increment though? It's automatically going to increment a value. What does this mean practically though? It means that when we do an insert statement, we're not going to have to figure out what ID number to put in. It will automatically do that for us. So once we get into the insert statement, it'll make more sense. But essentially, what we're going to do is say insert into, and then say some table, let's say users. And then inside of here, you can put what columns you want to put, and you can leave out the ID, so you don't have to put the ID. But you can put everything else. And then you put all those columns there, and then you say values, and you can leave out the user ID. You don't even have to worry about it because it's not even expecting the user ID up here. It'll automatically take the highest value that's in the table for the user ID and add 1 to it for the new value. So that way we don't have to worry about adding 1 to our value all of the time. That's super useful because that basically just allows us to ignore the IDs. It's only for the database. We don't even have to think about it. That's one thing I was going to talk about in this video. The other thing we're going to talk about is compound or composite keys. A composite key is a key that consists of multiple columns. And the reason you would do this is if you need to figure out a way to make the table unique, and one ID or one column is not enough to do it. You will often see this inside of an intermediary table. So if you don't remember what an intermediary table is, it's the table in the middle of a many-to-many relationship. So we break up a many-to-many relationship into 2 one-to-many relationships. And in this situation, this table is going to have 2 IDs. An ID for this table and an ID for that table. And one ID, for example, if we have an ID over here of 7, it can repeat as many times as it wants. But the thing is, the combination of that ID with an ID of this ID needs to be unique. So it's a little confusing, but let's say we have 7, 6, 7, 8, and 7, 9. So this is a little small, so let's blow this up a little bit. We could as well have a row such as 6, 9. So in this situation, the 6 is repeating, and the 7s are repeating. So we couldn't just use 1 as the primary key. That's because it's not enough information to force every row to be unique. So what that means is we need to actually make the combination like this the primary key. In that situation, that is an example of a composite key. Now, if both of the columns are keys themselves, in this situation foreign keys that point to these tables, it's known as a compound key. But the distinction is small, so I wouldn't get uptight about it if someone says composite or compound. Just think of them as the same thing, a key with multiple columns. And remember that the time you need to do that is when one column is not enough to make each row unique. This table in the middle here is basically an association table. You only want a specific association to be in there one time, but not a specific ID over here or a specific ID over here. Because then think about it. That means this one here could not be associated with any other IDs except 6. That'd be stupid. We want to be able to repeat the 7 as many times as we want, but we don't want the combination of 7, 6 to be repeated. In that situation, you would want to use a composite key. And you can do that when you create the table. At the bottom, you can say primary key, and then you can say what columns you want it to be. And you can throw in 2 or more columns. This is often a lot more common with natural keys, which is just a column that has actual meaning. That's because it often takes a couple columns to make the rows unique. So that's just a rough overview. If you didn't grasp everything in here, that's okay, because once we start creating this information and putting this into an actual database, it's going to make a lot more sense. This is more concept stuff, so when we get there, you're not completely lost. But don't worry about the details of, oh, how do I create this? What's the syntax and all of that stuff? Worry about that when we get to the create table statement. Thanks, guys. Hopefully that was helpful. If you guys like this video, please click like. And as always, click subscribe, because that really helps this channel, it helps my channel grow, and it helps other people know that I make good content. So if you want to help my channel, click subscribe, and I will see you in the next video. Be sure to check the next video out, though, because we're going to be talking about foreign keys, which are very, 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 very useful. Thanks, guys. I'll see you then. Merry Christmas, everyone. It's Caleb from Caleb the Video Maker 2. This video, we are going to be discussing... for some reason I forget. Foreign keys! Just like in the primary keys video, I said we kind of sprinkled this information throughout the series, but this one's kind of just going to put it all together, but mostly we are going to be discussing column attributes related to foreign keys. So, foreign keys reference primary keys. When you make a column a foreign key, you are saying every single value in this column has to be a value that exists in whatever column we're referencing. That's essentially what a foreign key is. Now, a foreign key has to reference a column that is unique. Kind of goes back to that example I gave you of some guy coming up to you on the street and asking you for some information. If you don't have a specific way on how to identify a row, it's hard to reference that data. Same thing applies for foreign keys. The foreign key needs something it can reference that is unique, so that way it knows exactly what row you were talking about. This would also include primary keys, because primary keys themselves are unique. Now, when you create a primary key, I'll put that over here, it is automatically unique and not null. What about foreign keys? Well, foreign keys are not these by default. This is something you have to choose. Do you want the foreign key column to be unique? Do you want the foreign key column to be not null? And that requires some thinking on how we want these databases to be designed. So the easiest way to think about this is, rather than having tables referenced this way, it's to rotate the whole thing and create parents and children. So the foreign key down here is the child. PK up here, the primary key, is the parent. This allows us to kind of think about things a little bit differently. Put this into like a family tree kind of thing. So when we do this, rather than thinking of a column referencing another column, think of an individual row referencing an individual row. Because when we make a foreign key column, that's essentially what we're saying. We're saying a row for this column has to reference another row. So to make that a little bit more concrete, let's use some actual data. Here we have a row, and it has a column with the value of 7. And here we have a child row that has a value of 7 pointing back to that 7. So this here would be inside of a foreign key column. So if you wanted to draw that out, we'd have a table, probably an ID for this table, and then an ID for the other table. And this would be a foreign key. So we could have like 2, 7, for example. We could have 3, 7. We could have 4, 8. This individual row references this parent. So does this row. So we actually have 2 rows that reference this parent. So that's kind of the way this design works. This is how foreign keys work. So we're just going to write parent and then 2 children. Now we need to ask ourselves, what is the unique and not null constraints going to do to these rows? So first, let's draw these out. The first one, unique. That means if we have a child with like the ID of 7 referencing the parent, we cannot have another child referencing the same parent. That would not work. This is basically the way you design a one-to-one relationship over 2 tables. That means this child is going to have to reference a different parent. So here the child references the parent, and here the child references the parent. But we can't have 2 children referencing one parent. That's what the unique constraint will do. And I call these attributes. That's another name, but there's a slight difference, and we'll discuss that in a future video. But essentially, an attribute can be a constraint. These are both examples of constraints, but not all attributes are constraints. Sorry, kind of off topic, so don't worry about that, but that's what the unique constraint is going to do. So if we have 2 tables, and we'll draw each row as a line, just for simplicity, and let's say this is the primary key, and this is the foreign key. One row can reference one parent, but that parent cannot be referenced by another column. That's not allowed. That means there's exclusivity between this child and this parent. That's the only association. We can't have it like this or anything like that. Now what about the not null constraint? What that's going to do is basically force every single child to have a parent. So if we have another child over here, we could theoretically have a null for the value of what the parent is. And in that situation, there would be no parent. But if we say not null, we're basically saying every single child has to have a parent. But if we're using unique, we couldn't do that. We'd have to point it to a different parent. So whenever you have a foreign key, ask yourself the 2 questions. Should it be unique, and should it be not null? Would it make sense for the child to exist with no parent, just orphaned all by himself? Or does it make sense that it has to have a parent? It really just depends on what you're working with. More often than not null is going to be applied, but not always. So that's a rough overview of unique and not null for foreign keys. Hopefully that was helpful. I know we didn't discuss everything in foreign keys, and because of that, we're going to talk about them a little bit more in the next video. So be sure to watch that, because we are going to be discussing the onDelete and onUpdate clauses. These are 2 more things you need to consider when you're creating foreign keys. So that's all for this video, guys. Thanks for watching. Please be sure to subscribe and click like on this video, and I will see you in the next one. Yeah. Hey guys, welcome back. This video we are going to be discussing onDelete with foreign keys. My name is Caleb from Caleb the Video Maker 2, and I hope you guys enjoyed the video. OnDelete is essentially a way we can configure the way our foreign keys work. And it kind of goes back to the last video, so I really recommend you watch that. We are going to discuss parent and children. So we're going to have a parent row, which is the row being referenced, and then we're going to have the child, which is the row referencing that parent. And we need to discuss what happens when we delete the parent. What happens to the child? Well, there's actually 4 options with MySQL, and the options are restrict, cascade, and set null. And we are going to be discussing each one of these. Now, there's also no action, which is just another name for restrict, but it's not always the same thing in different database management systems. So if you ever use a different database, know that there might be a difference between no action and restrict. But in MySQL, they're the same thing. So restrict, that's the default. So if you just make a foreign key and you don't say anything, like you don't put on delete something, the one that's going to be applied is restrict. Overall, these are pretty easy to understand. It's more important that you just know that they're there in case you need to use them. So the parent and then the child. The first one, restrict, is literally just going to prevent us from deleting the parent. That's the default, so if you go and delete the parent row, you're going to get an error, and MySQL is not going to let you do that. Cascade, on the other hand, will actually send the same command down to the child and delete the child. So if we delete this parent row, the child row will be deleted as well. Now if we go to set null, what that means is that the field within this child row that references the parent. So let's say this is all the information. We have maybe an ID of 7, and it depends on what the table's about. But let's say it's a user's table. We might have a user's name, and then we'll have a column that references that parent. And if we, for some reason, delete this parent when onDelete is set to set null, what that'll do is replace whatever value that's here, referencing the parent, to null. That might be useful if you want to be able to delete the parent, but you don't want to also delete the child. Because if you did restrict, you couldn't delete the parent. If you did cascade, it would delete the child. But finally, set null will allow you to delete the parent without deleting the child. A lot of words there, it kind of gets complex, but I think once we go into actually creating tables, this will make a lot more sense, but it's really good to go through the conceptual stuff first, so then when you get there, you're not completely lost and we can just kind of do a little bit of refreshing. The important thing to remember here, though, is that this column cannot be set to not null, because you couldn't put a null inside of a not null column, so that's not going to work. And actually, there's another setting you can do, which is on update. This one is used a little bit less, but it essentially works the same way. But instead of deleting the parent, what we do is we actually change the value that's being referenced. So let's say we have the value 7, and we have the value 7 here, and we reference the 7, and then we change the 7 to 8. With restrict, it's just not going to let you change it, and it's going to force it to stay at 7. Cascade will send that change down to the child, and they'll both be changed to 8. Set null will literally just erase this value here. So that's kind of how all of those work, and the reason on update is used less is because primary keys are not supposed to change, so it's really only useful when you're referencing unique data that's not a primary key. So a foreign key can reference a unique column, but a unique column does not have to be the primary key. So this could reference a column that's unique, and theoretically that data could change. So that's where the onUpdate comes in. Now, where do you actually put this information? Well, when you create the foreign key, you will just append onDelete, whatever, onUpdate, whatever, and right there in the create table statement. But we'll get into all that when we get to the create table statement. So thank you guys. Hopefully that was helpful. If you like this video, please be sure to click subscribe, as that really helps my channel out. Click like, as that lets other people know this video wasn't a total piece of garbage. And that's all. So thank you guys for watching. I will see you in the next video. Hey everyone, it's Caleb from Caleb the Video Maker 2. Welcome back to your MySQL tutorial series. This video we are going to be covering normalization. This is going to be an introduction. That's because the next few videos are going to talk about each of the normal forms. If you have no idea what I'm talking about, don't worry about it, we'll get into it. But essentially, normalization is a process we go through when we're designing a database to help make sure our database has the right structure. Normalization. Now, everyone makes normalization way too stinking complicated, so I'm going to try and explain it in English. But essentially, normalization has 3 main steps, and they're called normal forms. We have first normal form, second normal form, and of course, third normal form. There are a couple others after these if you want to research more, but I think once you get to third normal form, you can say that your database is pretty well normalized. Normalized is kind of like the finish line. So if you've learned about normalization and it doesn't really click with you, essentially think of it as pouring dirty water into filters, okay? The dirty water is your database, the filters are the normal forms, and you have 3 filters. The top filter has very big holes, so this just gets rid of like the obvious things you shouldn't drink, like rocks and snakes and scorpions and explosives. It gets rid of all of those ones. The second normal form has a little bit smaller holes. So this is going to get rid of, dirt. And then finally, the third normal form has like really, really, really small holes. So that's going to get rid of like bacteria, viruses, all of that good stuff. Now, this is an illustration, so it doesn't apply directly to databases. But essentially, after you get through all of those filters, you're going to have nearly pure water. If you want, you can add more filters by adding more normal forms. But there's a consequence in that the database becomes more complex. Just like if you add 20 filters to a water filter, things become more complex and more disorganized. So when we use the normal forms, we are going to look at our database with a certain pair of eyes, or think of like glasses, and we're going to look for certain things that are wrong with our database structure and then fix those. Each normal form has to have the previous one done in order to do it. So second normal form requires that first normal form is already complete. Sort of like if you have these filters in the water filter, the second one is going to be hit after the first one is already done. Third normal form, same thing. It requires that second normal form be done. And obviously, if second normal form is done, first normal form is also done. So you have this chain. Now, when you study normalization, you are going to run across the term dependency. This is when something depends, no, not like the diapers. This is when something depends on something else. Essentially, think of a column describing whatever the table is. So a users table, every single column inside of the users table describes this user. You could say the user is the entity, and each thing describing it is the attribute. We can talk about a specific user using a primary key. So for example, we could have an ID. And that ID, for example, could be 7 for a specific user. Now when we describe this user, we might have something such as an email. This is an example of an attribute. This email depends on the user. That's because if we change the user to someone else, the potential of this changing is very high. That's because every user doesn't have the same email. So that is an example of a dependency. And there's different types of dependencies that we're going to talk about when we're going over these normal forms that are not okay. So for example, second normal form talks about something known as a partial dependency. Third normal form addresses something known as transitive dependencies. That being said, I'm not going to bog you down with all of the details because when you study this stuff online, people talk about dependencies more than they talk about databases and how to design them. So you end up reading an article and you have no idea what they're talking about. At least that's how it is for me, but I'm not a super genius unlike all the other people who do this kind of stuff. So hopefully because of that I can explain it in English. A question we have to ask now is, how do these normal forms work? How do they actually improve our database structure? The primary way they help us is by getting rid of redundancy. Redundancy is when we have something in a database more than once. For example, if we have a comments table, we might have a comment ID, poster ID, the actual message, and if applicable, any replies. So we'll store one reply in here. Now this is not the best way to design a table, and you'll see why in just a moment. Let's go through some example data. So the comment has the ID of 1032, just some random number, and this points back to a user with the ID of 702, for example, and the message can be anything. And this is the original comment, therefore it's not a reply, so we'll just say null. Then someone comes back and replies. And because this one is a reply to this message, all we gotta do is say our reply. And this person says, nope, I disagree. And the message we're replying to is the one that says great. And you can see that this is just an awful way to design this. That's because we have this message in here twice, and also this message cannot uniquely define a row. There could be 50 comments that have great. This here, though, is an example of redundancy. That's because we have the same data in here twice. And now let's say in our application, this person goes back and edits their comment. So he grabs his comment, the guy who posted this one, great, and changes it to, okay. So to do this, we would use an update statement and say, update the message of the comment with the comment ID of 1032 and change it to whatever we want to change it to. But this is dumb because it doesn't update this one. This is an example of an anomaly. An anomaly is when something does not work the way it's expected to work. It's out of the ordinary. With database normalization, though, we can prevent anomalies. But do keep in mind that this builds off of relationships. So that's something we talked about in previous videos. I highly recommend you remember how to design a one-to-one, a one-to-many, and a many-to-many relationship. Because just doing that alone would help us to understand how to design tables pretty good. We also need to have a foundation in primary keys and foreign keys, because that alone would help us understand that this is just a dumb way to design this. We'll get into the good ways to design things in the upcoming videos. But that's all I have for you guys for now, so thanks for watching. Sorry if I rambled in this video. I just wanted to make sure to give a good foundation for the upcoming videos over each of the normal forms. That's because this stuff is super important. So thanks guys, and as always, please click like, and if you enjoy this channel, please click subscribe. Thanks guys. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2, and welcome back to your MySQL tutorial series. This video we are going to start our discussion on first normal form. Now first normal form is our first layer of normalization. It gets rid of the most obvious, most simple mistakes in our database design. And first normal form really focuses on things being atomic or singularity. If you want to make sure your database adheres to first normal form, you want to make sure that every single column in a table is single. So if we have, let's say, we'll go off of this example we've been working on, an auctioning site. So this site people can sign up for and they can put items on there and sell them and make some money. And on this website, let's say you can put your social network links on there. So you can link to your Facebooks and your Twitters and your MySpaces and your LinkedIns and your Twitters, oh I already said that, and your YouTubes and your Google Pluses and your other social networks. So how would we set this up? Let's say we have a users table and we'll add some columns. We'll say user ID, email. Now this is where the first example of singularity comes in. Each column describes only one thing, an email. We don't have email and social networks. We split that out. In addition to that, we want our column headers to be singular. So we could have in here, I'm going to break the rules and say social networks with an S. This is breaking the rules because this implies that you're allowed to put multiple social networks in one row, which you're not. That's also breaking the rules of singularity. So each column has to describe one thing, and it has to describe only one of that one thing. So one email. In this situation, how would you put data in here? Well, you might have a user ID of, let's say, 10, an email, and then you could put your social network links on here. So you could say, you know, Facebook, comma, Twitter. But this is not single because we have two values for that column, which is breaking first normal form. Now that we broke the rules, how do we go about fixing it? There's two ways we can fix this. The first one is in the column header. Don't make it plural. When we do that, we would imply that we only want one value. The downside to that is that you can only have one value. So we'd say our Facebook. So you could have your Facebook link, and you're limited to just one value in that column. If you wanted to try to put two, you'd have to figure out another workaround, such as adding a row. But the downside here is that we have this email repeating, and we have a primary key repeating, which is not okay. So this too is not going to work. So how do we fix this the other way? How do we allow us to be in first normal form, but also allow multiple social networks? The only possible way is to add a table. So we could have another table up here, and we can name it networks. Now it's going to have a couple columns. We could say ID, so each row is going to get an ID, and we could say user ID, and then network. So now each network is going to get an ID, so we could say 1, and then we could have the user ID of 10, and this is a reference, so this will be a foreign key to this column right here. And then we'll add the network in there. Obviously we would put the whole link to their Facebook, but that's fine for right now. Now that we have this, we can alter the original table. We actually don't even need this social networks column anymore. And we don't need this row because that's redundant information and it's not allowed. So the final result is just going to be a user ID and email, and then any other data that's related to the user goes in here. Any data related to the network would go in here. This is essentially making a one-to-many relationship. And you can go back and watch that video about one-to-many relationships. But essentially, this is going to have a foreign key, the user ID, and the parent is not even going to have anything referencing back to the children in the main table. So the users doesn't even need to know about the networks. Now this column here, you could potentially get away without having it because you could have this as the combination for the primary key. But in this situation, I think this way makes a little bit more sense. And that's how I'm going to go for that one for now. The last thing with first normal form is that every column needs to describe the entity. So in this situation, we have a user table. So that means we couldn't have a column over here like listing details. That's because this doesn't even describe the user. So everything inside of first normal form, you could summarize it as every column describes the key, the user ID in this situation. And every column describes it singularly. So each column is individual and there is no repeating rows. So if you make everything singular, I'm sure you will do just fine with first normal form. Now you might be asking, what about this here? Users. That's plural. Well, that's because it's a table for users, but each row describes only one user. You can't store two users in one row. So yeah guys, that's first normal form. Hopefully that was helpful. If you like this video, click like, and as always, be sure to subscribe because that really, really helps me out, and I appreciate it. So be sure to watch the next video, and I will see you then. Yo, what's up homies? It's Caleb from Caleb the Video Maker 2. This video we're going to be talking about second normal form. Now before we discuss second normal form, we need to remind ourselves of what a dependency is. Essentially a dependency is when something depends on something else. And in databases, that would be like an attribute describing an entity. So if we have an entity, we have attributes that describe this entity. This is a dependency. The attribute depends on the entity. Now when we're drawing this, you often see it as like, let's say, the ID, right? So the ID describes the entity. Then we have the email, for example. The email depends on the ID. Even though the arrow's drawn this way, this is saying when we change the ID from, let's say, 7 to 8, the email is going to change because it's talking about a different user. So if I lost you already, don't worry about that. I'm going to go through an example to make more sense. But essentially, you have to know that a dependency means when the thing we're talking about changes, the data describing it will also change. It's a very simple concept, almost so simple that we don't think about it, and then we get confused when we start talking about different types of dependencies. The reason it's important to kind of refresh your brain on this is that second normal form discusses a type of dependencies known as partial dependencies. Now, partial dependencies come in when we have compound or composite primary keys. Now, a composite key is a key that consists of multiple columns. So let's say this over here is a column, and this over here is a column, and these are in a table, right? And we could say that the combination of both of these columns are going to be the primary key. This other column is in here because it depends on the primary key. But when we have composite keys, it actually has to depend on both of the columns. If for any reason it only depends on one of the columns, we have what's known as a partial dependency. You will most often see second normal form come up when we have a many-to-many relationship. And let's go through an example now. In the previous videos, we discussed a database for a website where you can list items and sell them. And when we discussed many-to-many relationships, we made it so that a user could list something and share that listing with another user. So basically joint ownership of this item. So let's say I go on there and list a laptop and I want to split the profit with me and somebody else. So we have joint ownership of this listing. We had a many-to-many relationship. Let's draw that out and kind of refresh our brains. Over here we have the users. Over here we have the listings. And to amend this many-to-many relationship, we broke it up into two one-to-many relationships. So it looked like this. And this intermediary table was called user listings. So let's label the tables. Now the primary key in this table is actually a combination of a user and a listing. That's because you can think of this table as an association table. Once you associate a user with a listing, you're not going to have to do it a second time. So over here we'll have a user ID and a listing ID, and then the combination in here. Now, just for fun, let's say we have another column in this table. And we're running out of space, so let's just kind of blow it up down here. So this here is this table, just expand it a little bit more. So we added this column here, listing date. This is essentially going to record when the listing was created. The problem is that this listing date only depends on half of the primary key. Remember that the combination of these two are the primary key, but listing date is dependent only on listing ID. This is an example of a partial dependency. This kind of information does not belong in this table. It actually belongs in the listings table. That's because you could say what date and time the listing was created once for one individual listing. The reason you don't want it in here is because it's not relevant to the user ID as well. So what kind of data would you put in this table then? So second normal form would tell us to get rid of this column and put it in a different table that is relevant to just this part. Whenever you have something underscore, it's a good giveaway of what you're trying to describe. The listing. It doesn't say listing user, it doesn't say user, it just says listing. Therefore, the chances are it's supposed to go in the listings table. But what kind of data would be appropriate in this table? I want to put data in this table to show you guys what would belong here, but I don't want to break second normal form. Well, we need to find some kind of data that depends on the listing ID and the user ID. That means the data in here only describes the association between the user and the listing. So an example of a column might be the percentage of income when the item is sold. So let's go through some specific data so you can see how this works. Let me clean this up a little bit. Percent share. This would not go inside of the listing table. That's because it depends on which user. If an item, let's say we have a bicycle, and this is being sold by two people, we couldn't say a specific percentage inside of the listing table. For example, if we said 80%, is that discussing this user or is it discussing this user? We don't really know, so that's not very clear. That's why you wouldn't want to put something like the percentage share inside of the listing table. At the same time, you wouldn't want to put it in the user table though, because you might have one user selling multiple items. So he is selling a cheeseburger and some pizza. Yeah, I'm from America, don't judge me. And if you just gave a number, such as 80% share, well, does that describe the hamburger or the pizza? It doesn't belong inside of the user table. That means this data actually belongs to the association of the user and the listing. So let's say we have the user ID of 7, the listing ID of 13, and a user ID of 12. We'll make them both owners of a bicycle. So the user ID would be 7, the listing ID 13, and then user ID of 12, listing ID of 13. So going back to the picture I just erased, this bike would have the ID of 13. The users would have the IDs of 7 and 12. Now we can give it a percent share. We could say that the guy with the ID of 7 gets a 40% share. That means if the bike sells for $100, this guy is going to get $40. And we can give him a percent share of 60. And totaling, this adds up to 100, which would make sense. Unless, obviously, we're going to add fees, so this percentage, we could say it describes the income after we subtract the fees. So this kind of data is appropriate for this table. Hopefully that makes sense for you guys. That is second normal form. Just remember to get rid of any partial dependencies, and whenever you have a composite primary key, go through all of your attributes and ask yourself, does this belong here? Does it describe all of the columns inside of the primary key? If it does, it's appropriate. If it doesn't, it's not appropriate and you need to put it somewhere else. So thanks guys, that's all for second normal form. Be sure to check out the next video because we will be discussing third normal form. Thanks guys, and I will see you then. Oh, and if you want to help me out, click like and subscribe. Welcome back, it's Caleb the Video Maker 2. This video we are going to discuss third normal form. Now make sure you watch the previous two videos because these build upon each other. In order to be in third normal form, you have to first be in second normal form. In order to be in second normal form, you have to first be in first normal form. So it's kind of like this chain. Third normal form is going to be the most strict. That's because second normal form and first normal form have to be done, and it's going to have some of its own rules. So let's talk about those. Once again, this brings up the concept of dependencies. We discussed dependencies in the last video and a couple of other videos. But essentially, when you have a column, that column depends on the primary key. So on our bidding, selling website, let's say we have a listings table. And inside of this table, we're going to have the primary key of listing ID. We'll also have some other data. We might have a price and a category. And we'll also say what that category is about. So we have a category description, and that's going to describe the category. You could also have a column in here, item description, and that could be something custom to the user. So let's say you're selling a bicycle, you could say, hey, this bicycle's brand new, I've only driven it like 8 times. It's not very brand new, but that seems how people list things. It's super legit, it's autographed by this person, whatever. But the category description is something exclusive to our website. So for example, the category might be transportation. And then the description of this category is going to be the same for every transportation. So we could say stuff to get places. And that describes this category. So we'll add this bike on here. We'll say it's $100 and it has the listing ID of 1. Now let's say someone else gets on here and adds a car to the website. Listing ID of 2, its price is $3,000. Its category is transportation and it has the same category description. Now let's talk about what columns depend on the primary key. The price depends on the primary key because if you were to change the listing ID, you're going to be talking about a different item and the price will likely change. So this depends on what listing you're talking about. The category also depends on the listing ID. That's because every single item can have its own category. So if you change the listing ID, it'll be a new item and the category is able to change. Category description, believe it or not, actually describes on listing 2. That's because if you were to change the listing ID, let's say we had another item in here and it cost $10,000 and the category is toys. Now let's look at this value in relation to the primary key. If we change the primary key from 1 to 3, so we stop talking about the entity with the ID of 1 and we start talking about the entity with the ID of 3, you can see that the category description does change. So it does depend on the listing ID. That is in contrast to a column that's completely irrelevant. For example, you could have a column of the top selling items for that day. That's completely irrelevant to the listing ID, and even if you change the listing ID and go through all of the different items, the top selling item for the day is always going to be the same. So that would not depend on the listing ID. The odd thing though about this column is it's a type of dependency known as a transitive dependency. And what that means is it depends on the primary key through another column. So it actually depends on this category, which depends on the listing. So this arrow can be erased, and you can see that the category description is still connecting to the listing ID. So you get this kind of hop. These are bad, and third normal form says you're not allowed to have transitive dependencies. The solution to fix this is actually very easy. So you start at the primary key and follow the arrow back one time, and you grab this column here, category, and you break that off into its own table, categories. And now, all we have to do is have a category ID, and then we can put all of our categories in this table. So the category ID, category description. Then we take this category and move it down here. So we could give it a category ID of 1, and then the category would be transportation, and then the category description would be stuff to get places. And now you can replace this with a reference. So the category is going to be 1. Same for this one. And you can see it reduces redundant data by adding another table. 1. And this is redundant too because we have all this information in here twice that we don't need. We can actually just get rid of this column altogether. And we also need to add this row though. So we'll say 2 toys fun for all. And then when we need to reference this row, we can just put a 2. And that means this column is no longer needed. That's it for third normal form. Hopefully you guys understand that whenever you have a transitive dependency, all you have to do is grab what the closest to the primary key. So you could have multiple jumps, for example. You want to grab this one and put it into its own table. And the chances are you'll have this problem again and you'll need to put that into its own table. If you like this video, be sure to click like. And if you're new to this channel, click subscribe because that'll help you get notified of all of my upcoming videos. And on the bright side, it's free. Yeah, it's free. free. It's free. So thank you guys. I'll see you in the next video. Welcome back everyone to Caleb the Video Maker 2. The goal of this video is to summarize the 3 normal forms. Now I'm not going to go through and discuss all of the same information I just talked about because that's redundant. And as you learn from database normalization, redundancy is bad. But who am I to say that, because I've made normalization videos for Oracle, MySQL, and SQL Server, and database design. So talk about redundancy. Anywho, let's get on with this summary. So we have 3 normal forms. And if you had to summarize all of these, they all talk about how data relates to the key. So first normal form, the goal is to make sure every single column is singular. So each attribute is one column, and every column relates to the key. So when we have a table, we want to make sure all of the columns in there are singular or atomic, and every single column is relevant to that primary key. So if it's a users table, we want to make sure all of the data is relevant to a single user. The second normal form deals with partial dependencies. Essentially, we could word this that every single column has to describe the entire key. If we have a partial dependency, the data only describes part of the key, so that's not allowed if you want to follow second normal form. Finally, third normal form deals with transitive dependencies. That is when a column does depend on the primary key, but through another column, so you get that bouncing with the arrows that I drew in the last video. Third normal form says that all data depends on only the key. So the solution to all of these is to make all of the columns atomic. That's a pretty simple solution. For second normal form, take any partial dependencies and move them to a different table, or just get rid of them. For third normal form, you find all the transitive dependencies, take them and move them to their own table, and then in the original table, you reference them with a foreign key. So if you want to make this correct, every single attribute or column describes only the key, which means we have to get rid of transitive dependencies. To sum up everything, all of the data depends on the key, the entire key, and only the key. A lot of people word it saying the data depends on the key, the entire key, and nothing but the key. And now you could say our data is normalized. Hopefully you guys grasp normalization. If you like this video, be sure to click like. And as always, if you want to study more on this, I have other videos in different series. Also, you can look it up online and learn about some of the other normal forms. But for now, I think third normal form is more than adequate for what we are trying to do. So I would consider our database to be normalized if we got to third normal form. Thank you guys. Once again, be sure to click like and subscribe to this channel if you want to support Caleb the Video Maker 2. Hey, what is up everyone? It is Caleb from Caleb the Video Maker 2, and welcome back to your MySQL tutorial series. Now this is video number 23 in the series, and starting with this video, we are doing a competition between MySQL, SQL Server, and Oracle to see which one you guys like the most. So the winner is going to get 50 extra videos in the series. So if you're liking MySQL the most, be sure to click like and watch the rest of the series. In addition to watching the rest of the series, it's very important that you go back and watch the beginning of the series. Now, I know the content is so last year, but everything from video 1 to 22 is foundational to the rest of the series. Once you got that down, it's time to move on to data types. What? I don't even know what I said there. It was like, what? Mixed with woot? I don't know. Data types is an extremely important topic when we're talking about creating databases. That's because every single piece of information we store in a database has to have a data type. So when we create a table, we have to give the columns right here. And let's say we say food ID. This is not enough for the table. Following the column name, we have to put the data type of the data that's going to be stored inside of this column. So think of us having a table. One of the columns is food ID. Every single value for this column, every single row is going to have data of a certain data type. What is the benefit of this though? Well, if the database has all of the same type of data for a column, it's able to work with that data faster, it's able to optimize storage, and it's able to restrict incorrect data, data that doesn't fit that data type. But I might be jumping ahead. Did we really figure out what a data type is? A data type, put simply, is the type of data. I know that totally wasn't helpful, but think of the type of data. And we can categorize the types into 3 main categories. These are like the 3 categories we start with, and then later hopefully we'll learn some more. The 3 categories include numeric, string, and temporal. Now within each of these categories, there are specific data types that we are going to learn about. But if we're just talking about categories, what determines a numeric data type? Well, it's actually anything dealing with numbers. And generally, these are numbers that we can quantize? I don't remember the word, but any number that has actual numeric meaning. So for example, this column here has numeric meaning because we are going to be storing an ID here. But if we had a phone number, which I know doesn't really go well with a food table, but let's just say, well, those numbers don't actually have numeric meaning. Essentially, the important thing to know is that numeric data types deal with numbers. So think salaries, IDs, prices, discounts, etc., Moving on to string data. This is anything within quotes. So think of something like this. This is a string. Now in databases, it's generally approved that we want to use single quotes for strings. Now each one of these is known as a character. So there's 5 characters, H-E-L-L-O. And other characters would include numbers. Yeah, you can actually store numbers in a string. So you could say that strings are alphanumeric, meaning alpha for alphabet and numeric for numbers. But the database interprets that data differently because we say it is of type string. Other data that you could put in quotes include symbols. You can put spaces, new line characters, and even symbols from different languages. And lastly, we have the temporal data type. This is anything dealing with dates and time. So if you think you want to store a date or the time that something was done, you will want to use a data type that is of the temporal category. And as always, the categories kind of just help us out, but we don't actually have to tell the database what category we are using. For example, in this create table, if we put something here, such as int, that's enough for the database. We don't have to say int numeric or something. It's redundant because that's all the database is going to need to know how to treat this column. Now one last thing with data types is to consider storage. So Onyx, bless you. So with storage, certain data types allow us to change how much data we can store in that column. And the general rule is that you want to store the minimum that is enough to store what we need. For example, if we know that we are going to store only maybe 20 rows in this ID column, there would be no benefit of grabbing the largest numeric data type. The same thing goes with strings. If we know we are going to be storing strings that are never longer than 15 characters, for example, let's say we're storing phone numbers, there's no need to make a string data type that is like stinking huge, okay? Just keep it to the smallest that is needed and no extra. If you're unsure though, be sure to go on the larger size because it would be better to be on that side than to be too small and have to go and change things. Overall, that's a pretty rough introduction to data types. Hopefully in the next upcoming videos you will learn more data types in more depth, and that will allow us to create our tables really super good. See you guys. Oh, dang it. Oh. Look at it. So yeah, guys. See you in the next video. And as always, please sure to click like and subscribe. Yeah, I don't have anything else to say. See you then. Hey, what's up everyone? Welcome back to your MySQL tutorial series. This video we're going to be covering data types. Now, it's going to take a couple videos to talk about data types and go through all the stuff we need to go through. So I decided that I'm going to just create one video to introduce to you the most common data types. That was good. I like that. It's pleasant. Now, the very first data type you need to know about is char. Char is a data type that is known as a fixed length data type. And what that means is every single value for a char column is going to be of the same length. So if you have a table and one of the columns is of type char, and let's say it's char 10, every single value for that column is going to be 10 characters. What does that mean practically though? That means if you put something like this, which only has 5 characters, it's actually still going to store 10. It's just going to pad it with space. So it'll be, and you can see all of this wasted space right here. So when would you want to use a char data type? You would want to use it when all of the data is going to be of the same length. For example, zip codes, phone numbers, state abbreviations, anything that is consistent in the length. If this is not what you want, and you want to be able to store a variable length of characters without having to pad it with a bunch of spaces, you will want to use the data type varchar. Varchar works essentially the same way as char, but it doesn't pad your strings to fit a certain length. That means when you declare a varchar, you declare the max length, not the total length for every single value. So if you said varchar 50, every value can have a maximum of up to 50 characters, but it doesn't have to have 50 characters. You would want to use this if your data changes, for example, names, emails, product codes, anything that has a variable length. These are the data types you're going to want to use when you are storing string data. But what if you are storing numbers? Well, we don't want to use these character data types. We want to have data types specifically for numbers. So let's talk about those now. The first numeric data type is int. Int stands for integers, and integers are whole numbers. That means there cannot be a decimal point in fractions of a number. These are often used for IDs. If you do want to have data after a decimal, you can use the designated decimal type. This data type will allow for data after the decimal, and it can be used for perfect math. So that means if you're doing math with something like money, now you can also use int for math, but the thing is, int does not allow for anything after a decimal. So anytime you have numbers like 10.5 and you want to add that with another number, you will want to use the decimal data type. But you're only going to want to use that type if you need perfect math, meaning you can't gain fractions of a penny or lose fractions of a penny. If it is okay to kind of waver on the precision a little bit, you can use the double type. This is the preferred data type when you're working with numbers that you don't have to be perfect on precision. For example, if you had the number 10.1457638, and it's okay if it's a little bit different, such as 1457639. Well, you can see here that there's a very minor difference between these. And in some situation that's okay. For example, if you're measuring something to 5 significant figures, then it's okay to lose a little bit precision at the very far end of the decimal. So if your data does not have to be completely exact when you're doing math or trying to store very precise data, it is okay to use the double data type. But once again, if you need perfection when you're doing math, you will want to use the decimal or integer data type. And if that was a little overwhelming or too much information, we're going to go more in depth with this and kind of explain everything I mean. This video is just designed as an overview to introduce you to the different data types. Now, numeric data types can have two options, signed and unsigned. The difference between these two is that signed will allow for negative numbers, where unsigned will not allow for negative numbers. The reason you would want to use unsigned is because it allows you to have higher positive numbers. So for example, if you're working with IDs, the chances are they'll never be negative, so you could make the data type unsigned, and then you can store more IDs in your table. In addition to numeric data, we will often want to store dates, so that's what we are going to talk about now. The first 3 data types I'm going to teach you are date, time, and date time. And it's pretty obvious what each one of these can store. You can use each one of these to store a specific moment in time. There is also another data type known as a timestamp, and there are some differences between these 3 data types and this one, but they can both be used to store some instance in time. So we will discuss the differences in the upcoming videos, but for now, know that if you need to store a date or a time, you can use one of these 4 data types. So that's all the information I have for this video. Hopefully it was helpful. I just wanted to give you a good intro to the data types, so then when we discuss them, you already have those synaptic connections and things that go on in your brain. So once again, click like on this video and please be sure to subscribe to my channel to help me out, and I'll see you in the next one. Hey, what is up, internet? It's Caleb from Caleb the Video Maker 2. This video is going to continue your MySQL tutorial series. Now we are going to be talking about data types for the next few videos, and the ones we are going to start with are the character data types, or string data types. We've discussed char and varchar, and I'm going to discuss those in more detail in this video and the next video. Specifically, we will start with char. So when we have a column in a table, we have to specify the data type. One of the available data types is char, and this is a fixed length data type. And what that means is that every single value for that column is of the same length. And we actually specify that length in parentheses when we declare that column. So something like this. This 50 here refers to characters. Now I'm going to go off topic just a little bit because there's something I wanted to introduce to you. How do we know what kind of characters we're allowed to put in there? Can we use English? Can we use Arabic? Can we use Chinese? So forth. Well, this is determined by the character set of that column. And the character set that this is going to use is known as Unicode, which is one of the most common and most popular character sets. That's because it supports multiple languages. Now, the way this character set is actually interpreted by the computer is called the encoding. And the encoding that is used is known as UTF-8. So when you see UTF-8, think of Unicode character set. Now, you don't need to know all of the details of this. I just wanted to introduce you to it so then when you hear it, you're not dumbfounded. When a column is a fixed length, that means if you put something in shorter than that length, it's going to pad it with spaces. So something like hello only takes up 5 characters, but it's going to but it's going to pad it with 45 spaces. You can see that that's a problem. So you only want to use char when the data is fixed length or very close to that length. So for example, if we're going to have data that's always 10 characters long, we could say char 10. And because MySQL knows that every single value is going to be 10 characters, it doesn't have to keep a working knowledge of how long each string is. When we are talking about varchar though, which is the data type we'll talk about in the next video, this is a variable length character string. And what that means is MySQL has to keep track of how long that string is. So it actually takes up more storage. But if for some reason you're not storing 10 characters here, let's say you're only storing 7, that means there's going to be 3 characters wasted, because 7 plus 3 equals 10. That means char is only going to save you space if you are using the total number of characters. Now, what values are allowed in here? As of this video, the lowest value you can give is actually 0, and the highest is 255. So if you had 0, the only thing that would be allowed is null and empty strings. So an empty string is just a string with no data, not any spaces, nothing. 255, where does that number come from? Well, this has to do with binary, which there's a lot of information in this video, so I'll try not to overwhelm you with binary now. But this is the maximum number for an 8-bit number. So in binary, you could have zeros or ones. So if we have 8 ones, this number represents 255. 0, on the other hand, would be this. But the goal of this video is not to teach you binary. I do have other videos over that if you're interested. Bless you! Now, like I said, if you put a string in here that's shorter than 50 characters, it's going to pad it with spaces. But the thing is, when you take that data back out, MySQL is going to strip those spaces, so it doesn't look like it's padded. Now I'm going to introduce you to something known as an SQL mode, and one of those is pad char to full length. It's a pretty long name, but you can actually turn this on, and I'm not going to discuss how to do that in this video. If you want to know, you can look it up on the internet. But when this is turned on, MySQL is no longer going to strip those spaces out when it's returned. So if you do a select statement on a column of 50 characters and it only has 5 in there, it'll look something like this. And you can see that space. So yeah guys, that's all I have to say about char in this video. In the upcoming video, I'm going to be discussing varchar. So I'll be sure to see you guys then, if you go watch that video right now. If you like this video, please be sure to click like and subscribe to support my channel. Thanks everyone, I'll see you in the next one. What is up, guys? It's Caleb from Caleb the Video Maker, and it is so stinking cold. I have ostrich bumps. That's like negative 30 degrees. I really don't know what that means, but everyone says goosebumps. What's so special about a goose? This video we are going to be talking about. What are we going to talk about? I swear something's wrong with me. We're going to be talking about varchar. Make sure you watch the previous video which discusses the char data type, because a lot of that is foundational to the varchar data type. Now the special thing about varchar data types is that it doesn't pad our data. That means if we make a varchar of 50 characters and we put in something like hello, in a char data type it would pad it with 45 spaces, but varchar is literally going to store only 5. But there's the downside in that since all of the strings aren't the same length, MySQL is going to have to keep track of the length of each string. And that's going to make it mad, and because of that, it's going to punish you by making each string take up an extra byte or 2. So this will be 5 characters plus 1 byte. Now in this situation, each character is probably 1 byte each, but do keep in mind different encodings. So I haven't talked a ton on encodings, but UTF-8 is a very common one that allows for multiple different languages. English is going to be 1 byte each, but once you get into like Asian characters or some other languages, you are going to have up to 3 bytes each in MySQL. So this 5-character string could be up to potentially 16 bytes. It'd be 15 plus 1. Now we'll talk a little bit more about this 1 in just a little bit, because I said 1 or 2, but we'll worry about that in just a moment. Now the maximum size for a varchar column is 65,535 bytes. Now this is a per value measurement, so if you have a table, each row can have up to 65535 bytes. You also once again have to consider the encoding. For example, some characters can take up to 3 bytes. That means you automatically need to divide this by 3. And each row stores up to 2 bytes to keep track of how long that string is. So you need to subtract 2 from that. Additionally, MySQL has what's known as a row limit. The row limit is also 65535 bytes. That means if we try to make the max varchar, the row limit is going to be hit, and we're not going to be able to create any other columns that store any data. Now when you're using a character set such as UTF-8, each character can take up to 3 bytes, and MySQL takes that into consideration because it needs to know how much space to allocate for this column. So when you create a varchar and pass in something like 65,000, but you're using the UTF-8 encoding, that's not going to work because it's going to do the math and say 65,000 times 3 equals a ton. And it's going to pass that row limit. This is a little bit different than how char works, because if we say char 255, which is the max for char, you can store 255 characters regardless of whatever the size is. For varchar, since we have this row limit, we can't go all the way up to the max. That means you're limited to a little bit less than 1/3 of this. So to be on the safe side, I would never go past like 20,000. And that being said, you should never go over what you need. What I mean by that is if every row is only going to have 2,000 characters, there's no need to create a column that can store up to 20,000. Now I mentioned earlier that MySQL has to keep track of the length of the string, and I said it takes 1 or 2 bytes. Well, if the number of characters is 255 or less, it only takes 1 byte. If there's any more than that, it'll take 2 bytes. So if we talk a little bit more about storage, if you have an 8-bit number, which I know we haven't discussed binary a whole lot, but an 8-bit number allows for 8 zeros or ones. And we have the maximum for that. It would look like this. And if you take this binary number, that represents 255. We can't represent any more than 255 with this number. And if we need to go above 255, we actually add a byte. So that's an overview of varchar. Hopefully that was helpful. In the next video, we are going to be talking about another character type that you should know about. So be sure to check out that video. I will see you then. And if you've enjoyed this, be sure to click like and subscribe. Welcome back, everyone, to your MySQL tutorial. It's kind of confusing. Is it yours or is it mine? Anyways, this video we're going to be talking about the text data type. The text data type has actually not been discussed yet in this series, so something new. Ooh. Now, the text data type is a little bit different than the varchar data type, because the varchar data type, you can fit all possible range of values using one data type. But with text, it's actually split into 4 different data types depending on the size that you want. So we have text, and then we have tiny text, so that'd be smaller than text, but I'll just put it here, since this is kind of like the what they all have in common. Now the max size for these is 255, 65535. This one's about 16 million and about 4 billion. So as you can tell, these things can store a ton of data. Now this is measured in bytes. Now working with a text data type works exactly the same way as working with a varchar data type. The easiest way to explain text data types is to compare it with a varchar data type to see the primary differences. So that is what I'm going to get into now. The very first difference is that the text data types are not limited by the maximum row size in MySQL. So in the previous video we said that the max row limit was 65535 bytes. But you saw that some of the text data types allowed for much more than that. So how is that? Well, with the text data types, the data is actually stored elsewhere. So let's say this is our table. We will store our data over here and then reference that data over here. That's all behind the scenes to us though. It doesn't look any different. It's not used any different. This is all just the magic behind it. And what that means is that over here, there's only a maximum of 12 bytes used. So if you continually find yourself hitting this limit, it might be useful if you implement a text data type, so that way our data can be elsewhere and we save some space. That being said, there's also text data types that are larger than the maximum of varchar. So if for any reason varchar does not give you enough space to store the string you want to store in it, you can use a text data type and store way more. And lastly, a text column does not allow for a default other than null. So the only option for the default for a text column is null. But for varchar, we can do anything we want. So in summary, if you need more data in your rows, you can use text to separate it. Or if you need more data than the maximum varchar, you can use text. And finally, you can set a default in varchar that's not null, but you can't do that in text. So if any of those situations fit what you need, then you would know that you need to switch over to text or to varchar. In general, if you're not overly convinced you need to switch to text, then varchar will probably do just fine. Another thing I wanted to mention to you is that these text data types are sometimes called CLOBs, as stupid as that sounds. So a CLOB stands for Character Large Object. There's other types of large objects which we may discuss in the upcoming videos, but this is one. So if someone's talking about CLOBs, now you're not going to sound like an idiot. At least you'll know what they're talking about. So thanks guys. Hopefully this video was helpful. If you liked it, be sure to click like, subscribe, and I'll see you in the next video. Hey, what's up, World Wide Web? It's Caleb from Caleb the Video Maker 2. This video we are going to be talking about the MySQL enum or enum data type. Now this is short for enumeration. An enumeration in computer science is a data type where you can give a list of values and then whoever uses that enumeration has to pick one of those values. In MySQL, this is considered a character data type. We can list available options for a column, and then whoever uses that database, when they do something like an insert, they are going to have to insert one of those available values. Do you remember when we were talking about integrity a couple videos ago? Well, this could have been something added to the integrity list on how we enforce integrity, but I didn't think of it at the time. But this can enforce integrity by requiring certain data in a column. And it just started snowing. Now the secret behind enumerations is that everything is actually stored as a number. So let's go through an example and I'll explain how this all works. So let's go to our bidding website and let's say we can add an item on there to sell and we select a condition. And there's only so many options. So let's say these are the available options on our condition drop-down list. And the user gets to select one of these. That is an important thing when it comes to enumerations, is that they only get to choose one. These are all going to have what's known as an index. And this is not the same kind of index that a database table would have where we can index certain columns to improve speed. This kind of index is just a number. So new would have the index of 1, 2, 3, 4, and 5. And note that the index here starts at 1. This is interesting because in a lot of programming languages, the indexes start at 0. And actually, this thing does have an index 0. And that is actually going to point to an invalid value. So you could say that the index starts at 0, but the actual values that we created, these ones, start at 1. So this invalid is actually going to be stored as an empty string, so no data. There is also an option of null. So let me move this over. Null would be another option. And the index is, of course, null. So here are all of our options for this data type. Now within our table, this data is stored as numbers. So rather than storing, for example here, 1, 2, 3, 4, 5, 6, 7, 8, 9 characters, we can store one number and save a lot of space. But the important thing to know is that when you work with this column, it's not that odd. It's not like you're inserting a number. You still insert the string data, and the database does all the work for you of figuring out what number it's going to be. So a lot of this stuff goes on behind the scenes. Working with this data type is very similar to working with just a normal string data type like varchar or text. It's slightly different when we declare it. That's because we have to give all of the available options, but using it isn't a whole lot different. Now when you get into more complex things, this kind of stuff will come up, but when you're just working with basic inserts and selects, you don't have to worry a whole lot about this kind of stuff going on right here. Now a lot of people question the usefulness of the enum data type. That's because a lot of the stuff you can do with the enum data type can be done with database design. For example, we could create a table, condition, and the columns in here could be ID, condition, and maybe description. And now in another table, we could just make a column that references an ID. An ID is also just a number. So it would work essentially the same way, but we don't have to work with this confusing data type. There are a lot of other pluses and downsides to the enum data type. I'm not going to go into all of them because that's just out of the scope of this video, and most of them are out of the scope of this entire series. But just look up enum and you will see there are a lot of hard sides saying, no, you never want to use enum data type. It's non-standard, it's confusing, and it's just added complexity. And then the other people who embrace it. But I would say generally more people disagree with using the enum data type and prefer something like database design. In this situation, you could replace this with what's known as a lookup table. I have videos over these, so you can look up, that was totally unintentional. You can look up the lookup table and find my videos on it. Now how do you actually use this data type? Let's go over that now. Within whatever statement we are working with, let's say a create statement for example, and then we put the data type, all you have to do is say enum and then in parentheses list the values that are available within single quotes. So we could say new, very good, and these are separated by commas, and that's it. So for example, if this was in a create table, it would look like this, where we just have the column and then the data type, and then we end the create table. So once we got that, it's good. But how do we insert the data? It's very simple. All you gotta do is insert a string. And if the string matches one of these, then it will be inserted as that. If it doesn't match, then it will be inserted as an empty string. And that's it. Very simple. So thanks guys for watching this video. Hopefully it was helpful. In the next video, we are going to be talking about another data type that is very similar to enum, but it might be more useful for you in certain situations. So be sure to check that video out and be sure to click like and subscribe. And as always, I'll see you in the next video. I'm gonna go this way today. Welcome back everyone to Caleb the Video Maker 2. This is your MySQL tutorial series and we are going to be covering the set data type. Oh, it's already written there. Oh wait, you can't see it. Now, set. It's so similar to the enum or enum, however the heck you want to say it, data type. So make sure you watch the video over enum. If you have enum figured out, figuring out set is a piece of pie. Looking back at enum, it allows you to pick one of many options. Set, on the other hand, allows you to pick many of many options. So literally, you are going to pick a set of data, a group. One of the primary differences between set and enum is that with set, the number of available options you're allowed to have is much lower. In fact, you're only allowed to have 64, whereas with enum you can have thousands. Practically, you should never have more than 3,000, but even with that many options, I mean, that's a crap ton of options. You might not even need that many. 64, on the other hand, is a pretty small number. You might hit that. As with the enum type, the importance of the set data type can be thrown into question when you start talking about database design. I mean, think about it. Let's say we make a list of options, and we'll just make a couple here. And over here we have some rows. So let's say this is a row from a table, this is a row from a table, and this is a row from a table. And these can all be in the same table, that's fine. And one of the columns in that row is of the set data type. So let's say this row picks this one and this one. And this one picks this one and this one. And this one picks all three. You can see that an individual entity over here can pick multiple things over here. And an individual option can be picked by multiple things. So this is a many-to-many relationship. In database design, it is well known that you should never use sets. Now the set data type is a little bit different because it's designed to work as a set, but even so, you can avoid the set data type by having database design. We've discussed how to design many-to-many relationships when we were talking about relationships. All you would need is a table for this, a table for these options, and then an intermediary table to list the associations from one of these rows to one of these. So to go through an example, let's give these some IDs. 1, 2, 3, 1, 2, 3. Our intermediary table would look something like this. 1 goes to 1 and 1 goes to 2. So it would be like this. 1, 1, 1, 2. 2 goes to 1 and 2 goes to 3. So it'd have 2 to 1, 2 to 3, and then finally 3 to 1, 2, and 3. 3 to 1, 3 to 2, and 3 to 3. You get the point. So the set data type is really not needed, and a lot of people see it as a non-standard way of creating a database. That being said, I'm not a database expert. If you know there is a genuine reason to use the set data type, go for it. I won't tell anyone, except maybe your boss, and then I'll get you fired. I'm just kidding, but seriously. Now, let's talk about how to actually use this data type in case you do decide to use it. Let me clear off this board for you. You declare this data type just like you would the enum data type. So within a create table statement or an alter table statement, for example, you would give the column and then you would give the data type. And it would look something like this. Now, in order to show this, let's think of an example. In our bidding website, we can add items on there. We also have categories on this bidding website. So an item can be added to a category. But it's not always so that an item fits a category exactly. An item may fit multiple categories. So on our website, in this situation, rather than having a drop-down box where you can select one, you might have check boxes where you can select multiple. And in this situation, you could have all of the available options within a set data type. And you would literally just put the options in here with single quotes separated by commas. Now let's say we have an old antique car. The categories for this thing might be automotive, or automobile, transportation, and antique. So we are going to list these in this set. Now you normally would put all of the available options here, but for simplicity I'm just going to put the convenient 3 that we need. And that is how you would create the set data type. Now the difference between set and enum shows up when we are inserting data. So let's say we are inserting this data into the listings table. So we have one listing for this car. Insert into listings, values, and then once we got to that column, what we would do is we would quote and then put all of the values separated by commas. And there you go. Now notice the difference here. In this situation, we quote every single value. But for this situation, we quote the entire thing only one time and then separate each value by commas. Because of that, you don't want to use words that have commas in them because it's going to confuse MySQL. Now, if you were to add the same value in here twice, it would be ignored. And when you select this data back from the database, it's going to be organized in the order that it was declared. Additionally, something you need to be concerned about is what's known as a collation. And what this is, it has to do with character sets. It's how things are compared. And some of these are case sensitive. Some are case sensitive. If you're using a case sensitive collation for a column, you need to be careful when you're inserting data, because if you put something lowercase when it's supposed to be uppercase, you're going to cause some problems. So yeah, everyone, that is your introduction to the set data type. Hopefully that was good for you and nice and helpful. If you've enjoyed this, be sure to click like, and in the next video, we'll be talking about something new. So, well, I guess not that new. We're still gonna be talking about data types, but we're going to be moving on to numeric data types. So thanks guys, I will see you then, and be sure to subscribe. Welcome everyone to Caleb the Video Maker 2. This video is going to be talking about the integer data types in MySQL. Now int is short for integer. This data type is broken up into multiple data types, similar to how the text data type is broken up into multiple data types. But it's a lot different than the text data type, so don't use that as a reference. But I am going to break this up into all of the parts now. Here are the other available sizes. As for comparison to the int data type, it would go right here in size, which is kind of confusing if you're thinking about the text data type, because the text data type looks like this. So the text is in between tiny and medium. There's no such thing as a small text, and the biggest one is called long, not big. So there's literally no correlation with naming when it comes to int versus text. So don't associate sizes between these two. So I'm going to put that int in its right location so we can see it more clearly. The integer data type is a data type that is used for exact numbers. What that means is that the numbers do not lose precision. When you store a number and do math with it, you will always get the expected result. This is in contrast with other data types, which are for estimates, which we will discuss those very soon. Now each one of these has a maximum size of a number that they can store. If you want to know the exact numbers, you can look those up, but roughly I think this one's 255, 65535. This one's about 16 mil, and then this one is about 4 billion, and then this one is like thinking a ton. And these three are just estimates. Now, these values are for what are known as unsigned integers. And unsigned integers do not allow negative numbers. The benefit of that, though, is that the highest number you can store is much higher. That's in contrast to signed integers, where half of the range of values goes in the negative. So imagine this. Here is a number line. Here is 0. And let's say the range of values that are allowed is the size of this piece of chalk. If we had a signed integer, half of it would have to go in the negative and half of it would have to go in the positive. If it's unsigned, we can put all of it in the positive and get a higher number. Now the last thing I want to mention about the integer data types is that they are used to store whole numbers. Probably should have said that at the beginning, but you know, whatever. So that means 10 is allowed, but 10.5 is not allowed. If you want to store a decimal, you need to use either the decimal type or float or double, which we will talk about all of these in the upcoming videos. So thank you guys for watching this video. Hopefully it was helpful to you. If you've liked it, be sure to click like, and as always, be sure to subscribe. I'll see you in the next video. Welcome back to your MySQL tutorial series. This video we are going to be talking about the decimal data type. The decimal data type is similar to the int data type in that when you use it for math, it maintains its precision. The difference between decimal and int, though, is that the decimal data type allows numbers after a decimal point. So for example, we could store 10.5 inside of a decimal data type column. When you create a decimal column, you are going to define a certain number of digits that are allowed. So within here, you're going to put two numbers. The first number is the number of digits you can allow inside of that number. So let me erase this to not cause any confusion. And let's say the number is 5. That means within one row for this column, we can store a number that has up to 5 digits. The next number after the comma is the number of those digits that come after the decimal point. So for example, we could use the number 2. Now if we use these numbers on a column, the lowest number we could store would be negative 999.99. There's a total of 5 digits, 2 of which are after the decimal point. The highest number would be 999.99. Now this number here is known as the precision. This number is known as the scale. Now the max values for these, this one is 65 and this one is 30. And obviously this number is going to have to be bigger than this number. There are actually a couple of different names for the decimal data type. For example, it can also be named dec or dec, I guess, I don't know, numeric, and fixed. But in general, you're going to want to use this name. I think these are more for portability when we're talking about working with other databases. Now, why would you want to use the decimal data type? Mainly, it's for mathematical stuff that you need to maintain precision. So for example, if you were working with money, you're going to want to use the decimal data type. This is in contrast with the data types that are used for estimating, which we will be discussing very soon. So hopefully that was helpful for you guys. If you've appreciated these videos, be sure to click like and subscribe to the channel. Thanks guys, and I'll see you in the next one. You face. Sup everyone, it's Caleb from Caleb the Video Maker 2. This video we are going to be covering the floating point data types, specifically float and double. These data types are used to store estimated values. The numbers that they store can only be so precise. They are well known for causing problems when doing math problems. We will get some weird numbers and some odd results. And the reason that is because these data types are only capable of maintaining a certain level of precision. That means you only want to use these data types when you don't need exact values. If you do want exact values, you will want to use a fixed point data type is what they're known as, and that could be decimal. If you're using whole numbers, you could use int. And even if you're not using whole numbers, you could still use int and then do some kind of math on it. For example, if you wanted to store money in an int column, you could store it as cents. And then you could divide that number by 100 to get a dollar amount. But I'm getting off topic, so let's get back to the topic of floating point numbers. Why exactly are they called floating point? It has to do with the fact that we can present a number in multiple different ways. For example, let's say we have the number 150. Another way we could present this number is some number multiplied by 10 to the power of something. So for example, 1.5 times 10 to the second power. And if you work this out, you would get 1.5 times 100, because 10 to the second power is 100. And then 1.5 times 100 is 150. So you can see these are two different ways to present the same value. And if you think of where the decimal point is, in this situation it's here, and in this situation it's here. So you can kind of see it as floating across the numbers. I am probably going to butcher this entire explanation, but if you want to know tons of detail, look them all up online. For now, that's a pretty good explanation. Essentially, with this data type, behind the scenes, we are going to store some number and then store what we are going to multiply it by. This is known as scientific notation. Another way to present this would be 1.5 e2. That's just another representation of this same thing here. This e means times 10. So 1.5 times 10 to the second power. That means when we store a number in one of these data types, we're not just storing the number. We are storing the sign bit, whether it's positive or negative. We are storing what to multiply the number by, and we are storing the number itself. So when we have a certain size for one of these, for example, float takes up 4 bytes, not all of the bits within those 4 bytes are used to store a value. That's kind of a good thing, but it's also kind of a bad thing. It's a good thing because since we're storing some number to multiply by, it's going to allow us to store much larger numbers in a smaller amount of space. The downside though is because, let's say this is the number we are storing our data in, and this much is taken with this and a sign bit, well, this is all that's left for the actual number. Because of this, we have lower precision. So in summary, we have the benefit of storing larger numbers at the cost of having lower precision. Lower precision than what? I guess it'd be lower precision than if we stored the entire number as an exact value, such as using the decimal data type. Now you have to ask yourself a question, should I use this data type? Should I use either one of these? It really depends on the type of data you're storing, and sometimes it's perfectly fine. For example, let me clean this mess up. Let's say you have the number 15 trillion. I believe that would be this. You can see we are storing a huge number, but the actual two numbers that are most important to preserve are these two right here. That's because we can represent this number as 1.5 times 10 to the 13. In this situation, we don't need a whole lot of precision because we're only storing two numbers that are going to really be important to us. The length here is going to be preserved. What would change though is if we had like a 6 here, Well, it would be hard to ensure that the 6 is always going to be a 6. Especially when we get into doing math, you can get all kinds of funky results. So if we had some crazy number, as we go this way, we have less assurance of precision. Now, I said both of these are floating point numbers. So what exactly is the difference? Well, it just has to do with the size. Float is 4 bytes, as I said earlier, and double is 8 bytes. And because the double has more bytes, it can maintain a higher level of precision. So how much precision can you expect from these numbers? Well, a float, you should be able to maintain around 7 digits, and then with double, you can maintain around 15. The actual number you can store, though, is much stinking huger than 15 digits. So if we were trying to store something like this, we would be wise to pick the double data type. Now, in what situations do you want to use float? Well, in general, if you have the option, you most of the time are going to want to pick double. That's because, for obvious reasons, it has a higher level of precision, and MySQL does its calculations using the double data type. So with float, you can get some odd results. Now with double, you can get some odd results too, but you can get more odd results with the float. So I would bank on the side of trying to store all your data as the double data type, although that is not required. The ultimate decision is up to you, just be sure you understand the differences between these two data types. That's all I have to say about float and double. I know I didn't go in tons of detail, and honestly, this is a topic that is pretty confusing. I'm reading it online, I'm like, what? So I covered the bare minimum of what is required to understand what the float and double data types are, but if you want to know the exact specifics, go to Stack Overflow or Wikipedia or something like that. In conclusion, float and double are data types that can store tons of numbers, including numbers after a decimal point, but they don't maintain precision. If you're unsure whether you should use float or double, just remember this: prepare for trouble, make it double. I'll see you guys in the next video. Yo, what's up? It's Caleb back on the YouTubes. How you guys doing? This video we are going to be talking about date time, and time. So these are 3 data types that MySQL has to store dates and times. Yeah, I know. As you can tell, MySQL likes to really, separate things out, make a lot of extra data types for us simple-minded who like complexity, right? I'm kidding. It was a joke. Anywho, there are 3 data types used to do basically the same thing. So we have datetime, date, and time. And the difference between these are very obscure. I'm just playing, guys. Obviously. Okay, so let's start with datetime. Datetime is separated into date and time, which are essentially the same as these data types. So you can store 2 in 1 using datetime. Now there's something particularly special about labeling a column one of these data types, and that is that MySQL can work with that data specially. It knows that it's working with a date. You could, in theory, not use these data types. For example, you could have a varchar column, and within here you could say something like this. And this works fine. That's one way you can store dates, but overall it's just pretty craptastic. I need to become a little bit more professional here. This is a very unprofessional approach to doing things. Of course, I'm sure there are certain situations when you'll want to store a date as just a sequence of characters in a string, but in general, you are going to want to use a data type like datetime, date, or time. There's also timestamp, which we'll be getting into that in an upcoming video. So if you have a column that is of one of these data types, how do you give it the data? Is a date a number, or is it a string? Well, we just discussed that it wasn't a string, it works a little differently, so how do you do it? Well, you actually pass it as a string. So you quote it when you give it data. Now, what goes in this quote has to do with conventions. So as we've discussed, conventions are just an agreed upon something that everyone uses just to make life easier. So for example, if I give you something like this, and I say it's a time, well, you would say, yeah, the time is 6:30, and you know what that means. You automatically know that the 6, well, this is how it works in the USA. It works differently elsewhere. I apologize, I am uninformed. Anyways, this is the hour, and this is the minute. The colon here is just convention. We decided, hey, let's put a colon here. We could just put something else, we could have said 6 £30 or £6.30. It's a convention. Well, MySQL has its own way of representing dates and times, and we need to become familiar with how MySQL does that, or else we might think something else. For example, someone who doesn't know this convention might look at this. This is a bad example, but let's say it's like this. It's the 12th hour of the day, and it's the 6th minute, and then it's all confusing. So let's learn how MySQL represents dates and times. First, let's discuss dates. I will give you the way MySQL stores them, and then I'll show you some common ways that we as human beings express dates. So this is an example of a date that we could pass to MySQL. And it's very clear from this example which one is the year. Obviously that one because it has 4 numbers. But here's where ambiguity shows up. Which one of these is talking about the month and which one's talking about the day? You can, by this example, figure it out because 22 only makes sense in the context of it being a day. So in summary, this is the year, this is the month, and this is the day. This is in contrast to some ways we express dates as humans. Some people would represent this as this. Others would represent it like this. Some people would represent it like this. So you can see it's very important to understand what is what when we are working with dates. Now MySQL can be a little bit lenient in how you give it a date, and we'll be discussing that in a future video. But for now, understand that this is the standard format for a date. Now let's move on to the time. This is an example of a time where 22 is the hour, 54 is the minutes, and 30 is the seconds. And you can see that the delimiter or the separator is different. We have colons for the time and hyphens for the date. Now the hour, this might look interesting to some of you. This is in 24-hour time, or as some people would say, military time. So if you're not used to that, you can take 22, subtract 12, and we figure out that it's 10. So this would be the equivalent to 10:54 p.m. Now a cool thing with MySQL is that we can actually have fractional seconds. So we can put a period right here and add fractions up to 6 decimals, which I believe would be microseconds. But it's not very often I've worked with time that small, so in general, I don't really need any of this data and I don't really worry a whole lot about it. But this is something that can set MySQL apart from some other database management systems. Now, in order to do this, when you specify the data type, you have to give it some kind of precision in parentheses. So for example, we would say time 6, which would allow up to 6 decimal places. If you want less, you could do something like 3, which would limit you to just that many. Now let's say we have a column that is of the data type date, time, and we'll say precision of 6. How do we pass data into this? So let's go through a very concrete example of what we would give it. Everything is going to be inside of a quote, and we start with the date. Now after the date, we put a space, and we start with the time. And then after the time, we can put a period for fractional seconds. And there you go, that is an example of a date-time value. That is all I have for this video, although I do have more to say about date time, and also some of the other data types we're going to come across. So please stick with this series. If you've enjoyed it, please click like, subscribe, and as always, I'll see you in the next video. Thanks guys.